Good morning, afternoon, evening, wherever you may be. Rob here, Fairfax County, Fairfax, Virginia. Don't know if I'm live. It says that I'm live, so I'm going to check that. Oh, wow. Apologies to everybody. Yeah, working on very little sleep and all that kind of good stuff. And I don't even know if. Hold on. Let me see what this looks like on my end. Okay, go away. Computer just updated, so it's doing all kinds of lovely things. Content. Oh, what is this? Maybe this one? Nope. Let's go that one. How about this one? I am live. Excellent. Hey, and it looks like me. So sweet. Awesome. All right. Oh, howdy, Norm. Okay. All right. I don't want to. I skip. Whatever. It's weird because OBS is okay. Well, that works. Okay. Hey, howdy, sickness. Okay. Coffee. Yes. All right. Howdy, everyone. I am Professor Parks, PhD, and this is Coffee and Science. Again, apologies for all the mix-up. Lots of reasons, mundane and boring, and why. Anyway, so glad you all are here, and so glad that I could make it. Let me see here. I don't know who all is still here. We have Judy and Norm. Howdy. Rocky. Howdy. I see Eric was in the. Eric was in here earlier. Jeff. So before I begin. Oh, and howdy, Cygnus. Before I begin, I would like a heartfelt apology to PhD Tony, who I incorrectly referred to as a geologist. He is, in fact, a geophysicist. So I have to say that I wasn't quite aware of the distinction, but it makes sense. I am an astronomer, and there are astrophysicists, so that is my only excuse for such a what's the word I want to look? A failing of protocol, I guess. So, all right. Now, I'm going to. So, what are we going to talk about today? Well, to be honest, my original plan was to talk about relational motion and the book by Dr. Sun Genesis about whether or not, as some have claimed, a neo-tychonic model is in fact kinematically and dynamically equivalent to what we see today, the heliocentric model. And I had originally scheduled this for last week, obviously. And then I pushed it back. And then I pushed it back again. I pushed it back an entire week. Howdy, Mr. 42. I am definitely going to be checking out that stream, unless I completely already missed it. I'm going to be checking out that stream with huge R's. So, I think that's later on today. Anyway, so that was the original plan, and I am going to go over a little bit, but I got to be honest with you, folks, that I think one of the reasons why I pushed this back and one of the reasons why I wasn't overly prepared today is I don't really want to talk about it. I mean, this initially came to being, this idea came to being because it's been on my radar for a while, and I was informed that Mr. Witsit may in fact have been using my name or using an astronomy professor at an observatory to help legitimize his claim of equivalency between a neo-tychonic model and a neo-tychonic model and the heliocentric model. And so, I felt to myself, I should look into this and I should respond, or at least set the record straight. Howdy, Charlie. And I gotta say, I don't really care. Because life is too short. And, I don't want to... Life's too short, and I realize that I want to spend more time on what I feel to be objectively true, as opposed to theories that are not true, or at least I don't believe are objectively true, or cannot be objectively true. Yes, I suppose, if I wanted to be intellectually honest, and particularly in the things that I've talked about on this channel, I would look into relational mechanics, but I have been informed by friends of mine who are far more proficient in the mathematics behind this that it is flawed. And I had to say that when I looked into one of the books that Eric or Pedling, I'm pretty positive I butchered that last name, but Eric sent me. When I looked into it, I realized that in order for me to really do a deep dive on this, would have to spend a fair amount of time revisiting math I haven't done in a while. I am at this point I'm instructional faculty. My focus is on education. My focus is on learning new techniques to educate folks, so forth and so on. It's been a minute since I've had to derive an equation or go through any sort of rigorous mathematics. And I figured that, I could do this. I could look into this, or I could look into modern cosmology, because I am getting becoming more and more of the opinion that we may in fact see general relativity falsified within my lifespan, which would be awesome. To actually live through a major scientific revolution would just, chef's kiss. Now, the reason why I say that is because the Europeans, it just popped in my radar for reasons. I don't know why not before then. That the Europeans put up Euclid. And one of the things that Euclid is going to try to do is it has two experiments that will definitively be able to support or falsify general relativity. Now, general relativity at the moment has problems in the sense that there are questions about the universe, particularly the beginnings and the ending, potential endings of it, that general relativity doesn't have an answer for. That is not to say that it's wrong. That is just to say that it doesn't have an answer for it. As I was explaining to my students, there's a difference between not knowing something and guessing something and being wrong. Now, for example, there is a coefficient of, basically it's a coefficient which dictates the how quickly things evolve, structural-wise. How quickly do things form into larger structures, galaxies, superclusters, filaments, yada, yada, yada. General relativity makes a distinctive prediction about that. It also has something to say about the jerk. For those of you who are not in the know, the derivative of displacement or distance over time is called velocity. The derivative of velocity over time is called acceleration. The derivative of acceleration over time is called a jerk. And when we are looking at this dark energy expanding model, again, there is a definitive claim as to what that jerk is. From my understanding, the jerk would be zero. There is no change in the acceleration over time. Anyway, Euclid can answer that question as well. So, long story short, I want to spend more of my time, which I have very little of, looking into that, looking into the science that is that I view as the best descriptions of astronomy, cosmology. Not to say that I'm leaving the whole flat Earth thing by itself, but really with the flat Earth, what I would be most interested in is what I've been doing before, which is exploring why folks hold to science skepticism, as I've been hopefully politely referring to it as. So I'm not exact. So for example, I would love to have Dr. Sun Genesis on my channel to have a discussion. I would love to have, I think his name is Dr. Robert Bennett, on my channel for a discussion, not to discuss their ideas, but rather to discuss why they have their ideas and why it is they believe they're correct, I guess. And it occurs to me that I may have left the thought unfinished, but just to make sure that I finish it off. Yes, if I wanted to be intellectually honest, I suppose I should look into these things. I should look into his theories. I should figure out what's going on with them. But as I said, life's too short. I have other things that I want to concentrate my attentions on. Howdy, Dr. Bob. You have been doing some great imaging over there at Shamrock Banks Observatory. For those of you who are not aware, Dr. Bob is a citizen scientist who has built himself one hell of an observatory in his backyard on the coast of his lake. Shoreline of a lake. Again, 2 hours sleep, so we're going to go with it. And he's been doing some phenomenal work there with imaging and so forth. So, sadly, I've not had the opportunity to really been able to get on his live streams and watch him take this data. But, all right, let's do this. Let's put you over here. Let's put this over here. All right. I will, like I said, I am going to bring this up. I'm gonna look at this, but it's going to be more of the format of the last stream where I do this basically live. I do this as I go forward. Yeah, I haven't really prepped anything, so let's see if I can even find these documents. All right, I'm going to do that. Yes, okay. All right, let me see here. Personal. Hope you all are doing well out there in the YouTube lands. Is it this one? Okay. All right. Let's see here. there's a lot of windows here. What do I want to find? What is that, preview? That one. Okay. All right. I think I have some explaining to do, but let's see, because that's the that is the need to fix this. Whoops! What's going on here? Oh my gosh! Talk amongst yourselves while I do this. Tech is hard. For as much as, I have complained that flat earthers can't tech, really not much better. Trying to resize this thing. All right, let's go with that and just kind of go with it. Can I resize me? I think I can resize me to get this out of the way. Yeah, there we go. All right, let's have a look at this thing. This is by Andre Assis. So I know this isn't I don't believe this is the definitive book. Particularly, I don't know if whether or not what's his face Austin has been promoting this particular book or not. But this is the last one, or this is the one I've been most recently looked at. So when we look at this book, we have the old world, I guess Europe and such. You have Newtonian mechanics, which he covers in about 10 pages. Interesting. Applications of Newtonian mechanics, non-inertial reference frames, yada yada. Newton's gravitational paradox, Leibniz and Berkeley, Mach and Newton's mechanics, Einstein's theory of relativity, yada yada yada. I didn't look at any of that because unless this person is going to misrepresent it, I think I have a pretty good handle on that. It was the New World, America, that I was looking into. Relational mechanics, applications of relational mechanics, beyond Newton, so forth and so on. And I only got to chapter 8. So let's look at chapter 8, shall we? And yeah, we'll just get there. Eventually we'll get there. Chapter 8. All right. How do I keep this alive and yet still see me? There we go. How about that? There we go. All right. Basic concepts and postulates. Not to be confused with Carlo Rovelli's relational quantum mechanics. No, I'm not familiar with that, but yes. All right. We begin presenting some basic or primitive concepts necessary to define more complex. Can I highlight? I don't want to be sued by Illuminati, but we begin presenting some basic or primitive concepts necessary to define more complex ones. Always a good starting place. We do not define these basic concepts since we wish to avoid vicious circles. That seems like a cop-out. Basic or primitive concepts that we which we will need are 1. Gravitational mass, 2. Electric charge, 3. Distance between material bodies, 4. Time between physical events, and 5. Force or interaction between material bodies. Now here's the problem that I have. And again, maybe it's nitpicky, don't know, but the author at this point, first red flag I have, is that the author is not defining what gravitational mass is. That was a primary question. Well, rather, the primary question was whether or not gravitational mass, as defined by Newton's law of gravitation, was in fact the same as Newton's inertial mass, or F equals ma. And there was this lovely experiment, EOT, I don't even know how to spell it. Evotus, I don't know. Someone who's been sleeping better than I have can put it in the chat. But essentially, it was reminiscent of Cavendish, and it showed to a stupidly high precision that yes, in fact, the inertial mass as defined by Newton's second law is in fact the gravitational mass as defined by Newton's gravitational law. It may be possible to derive the gravitational force from an electrostatic force, as we've shown elsewhere. If this is the case, gravitational mass will not be a basic concept. Okay, well, I didn't look at that, so I find that to be interesting. It may be possible. This is supposedly a textbook, or at least it's structured in the way that it's a textbook on relational mechanics. So having such a qualifier as it may be possible, is it possible or not? I don't understand how in a textbook you need to be, or you should be, hedging your bets. As this has not been proven yet, we will be treating it as such. All right, now, here are the 3 postulates of relational mechanics. Which, the first 2, okay. A, force is a vectorial quantity describing the interaction between material bodies. All right, I got no qualms with that. B, the force that a point particle A exerts on a point particle B is equal and opposite to the force that B exerts on A and is directed along the straight line connecting A to B. It's been a while, but I'm pretty sure that's Newton's third law. I think. Could be wrong. Could be wrong. And yeah, I think I'm going to be a little salty today. Not happy with how this is set up. All right, let's do this. Let's do that. All right, cool. Let's do that. Sweet. Let's pop this out. Trying to be able to see the chat. For some reason, it doesn't want me to see the chat. Oh, that reminds me. Let's see. Not that I don't think Isaiah, whoever, what's his face, is going to show up. But, let's see. You get a moderator role. You get a moderator role. You get a moderator role. You do too. And how about you? Yes, you also become moderator. Excuse me, my nose is all kind of messed up. Anyway, what do we got here? So yes, I should have a few of you now should be mods on my YouTube channel. So congrats. Anyway, so B, his second postulate is, I don't know, Newton's third law, unless I'm missing something. Now here is the funky bit that is really the first kind of radical, well, not kind of, radical change to the difference. And that is the sum of all forces of any nature, gravitational, electric, mechanic, or magnetic, static, nuclear, etc., acting on any body, is always zero in all frames of reference. So again, maybe I'm just not sophisticated enough, but I see kind of a problem with that. Because what that tells me is that there cannot be an odd number of forces acting on a single object or a single system. There cannot be just one force acting on an object. Or 3, or 5, or whatever. Well, no, I'd take that back. There cannot be one. There could never be a system where you have only one force acting on something which is non-zero. But, yeah, so, and the other issue is that this is basically saying Newton's second law ain't a thing, I guess, because if the forces are all zero, the sum of the forces is all zero, then therefore Newton's second law would tell us that the acceleration on that system is also always zero, which in fact would then seem to tell us that you cannot, in fact, ever have a change in that system as described by Newton's first law. First law being object in motion tends to stay in motion unless acted upon by an unbalanced outside force, or object at rest, yada yada. So, but what he's eventually going to get to is that apparently in relational mechanics, and again, please, for those of you who are more knowledgeable, either now or in the comments, this author is basically going to tell us that inertia ain't a thing. That inertial mass, the reason why you may have wondered during his he specified his stating of five basic principles. Gravitational mass was one of them, but inertial mass seemed to be off that list. And the reason for that is because inertia ain't a thing. Or at least inertial mass ain't a thing. And so he uses this as an example of what he was talking about for his third principle. You have a proton, presumably, or you have two charged particles of equal charge but opposite sign, and then, so it's a electric dipole, and then you have charge 2 over here at R2. Yeah. Third postulate is the main departure from Newtonian mechanics. No kidding. We may call it the principle of dynamical equilibrium. It states that the sum of all forces on a body is always zero, even when the test body is in motion and accelerated relative to another body, to ourselves, or to any other frame of reference. Later on, we derive a law similar to Newton's second law of motion. The advantage of this postulate compared to Newton's second law of motion is that we do not introduce the concepts of inertia, inertial system of reference, inertial mass, and absolute space. Sure, I didn't realize that those were problems other than the absolute space problem thing. Yeah. In Newtonian mechanics, the sum of all forces is equal to the time variation of the linear momentum. True. Suppose a person on the Earth's surface throws a rock upward in the presence of a strong wind affecting the rock's motion. Person will apply the postulate that the resulting force acting on the rock is zero, even when the rock is rising, falling, stopping, and sitting there at rest. In the frame of the rock, we should also apply the postulate the resulting force acting on is always zero, and any other arbitrary. See, maybe he does later on in the text, which I haven't gotten to. Which, again, if I had more time and actually care a bit more, I would look into it and read. But I would like a little bit more of a description as to why, how rather. Basically, then he restates that third postulate in terms of energy: the sum of all interaction energies, gravitational, electromagnetic, elastic, nuclear, etc., between any body and all other bodies in the universe is always zero in all frames of reference. Once more, only the ratio of energies will be important. Again, naively, yeah, Norm, it seems like they're, for relational mechanics, for whatever reason, it seems like he's throwing out dynamics. I'm not entirely certain. But this postulate, or this restatement, just, again, looks to me like energy cannot be created nor destroyed. So, okay. The advantage of the postulate over the analogous postulate in classical mechanics, that the sum of kinetic and potential energies is constant, is that we do not introduce the concept of kinetic energy, because that would imply a inertial mass. Again, we derive an analog of this classical blah, 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 blah. Judy, I have no idea. I never quite got there. So this is the first part. This is basically where the author defines or puts forward the gravitational energy. This is electrostatics. Basically, this is their formulation of the Coulomb law. It's apparently has something to do with Mr. Wilhelm Weber, but again, I didn't bother to look into what that was. The thing here is that you have the energy between two charged particles is some constant times the charge of those two particles divided by the distance between them times 1 minus r dot squared over 2c squared. R dot, for those of you who are not familiar, that is a time derivative of displacement. So essentially, v squared over c squared. I will state this right now. For those of you who are sticklers about notation, this book would drive you nuts, because it kind of drove me nuts. Because, yeah, vector quantities, or vector arrows, things that differentiate or basically show that things are vectors, you don't really bother with that. So, yeah, c is the speed of light, so at least now, which is funny because he did not specify this earlier, and this is one of the specific postulates of special relativity, is that the speed of light has a definitive speed 3 times 10 to the 8th meters per second. The difference between one of the key differences between classical mechanics and relativity is that in classical mechanics, the communication of gravity was instantaneous. Essentially, one mass knew that another mass was present immediately. There was no delay in the communication as to when they should start attracting each other. Einstein said, nope, no. Actually, things cannot communicate any faster than the speed of light. The fact that this is just kind of thrown in there, yeah, all right. And like I said, there's this added term, for those of you in the know, basically if we look at this, if you make the assumption or go to the limit of V is very much smaller than C, this second term goes away, and you're left with just your normal, everyday Coulomb's law. In terms of, now let's look as R, or as velocity equals C, or in the range that V is equal to, or the limit that V is equal to C, this becomes 1. The energies between the charges is 0. So as one charge, presumably, as one charge is moving away from, or moving relative to another charge, as one charge is moving relative to another charge, as it gets closer and closer to the speed of light, the amount of energy of interaction between those two particles goes to 0. Okay. The force is just the derivative as a function of radius, or radial distance, energy over radial distance, blah, blah, blah. And you get this thing, this equation. So this would essentially, if you have that, again, R dot is velocity, R double dot is acceleration. We've arrived at this result in order to unify electrostatics with electrodynamics. Okay? This is what I'm talking about in terms of me not caring enough to actually go into the nitty-gritty details of this, because I would have to look into Faraday's law, and I would have to see how this, if this in fact unifies electrostatics and electrodynamics, because all I have here is a what's the word I'm looking for? Modification of Coulomb's law. If all things being equal, then this stuff on the side would just equal 1. Oh, also R hat with the little carroty thing, that's a unit vector. That basically just that indicates direction. So again, why not use vector hats or vector arrows? I don't know. For some reason, he decides to actually use unit vectors in order to specify direction. You got me. I don't know. He also throws in this negative value for reasons. Again, doesn't specify why. It's well, actually. Never mind. I know why. It's due to, actually no. The negative value throws that in there. No idea why. And it cancels out because of the derivative. But let's look at this. Let's look at this in terms of limits. I always like doing that. So in the limit that the velocity is much, much smaller than c, this term over here becomes 0. Groovy. Which means that the Coulomb's law, as written now, is Coulomb's law as we know and love, plus this thing. Which means that Coulomb's law, the force between, or Coulomb's law, has a component, an added component that is directly related to distance. So there is an additive part of the equation that is a where the force goes up directly with distance. So part of the force apparently increases as you separate distance, or at least, I'm sorry, that would somehow you pull that out. I don't know. At least in a certain sense, the force does not drop as fast. And then you have this acceleration term. So if two particles are not moving, or they are moving relative to each other at a low speed, and that velocity is not accelerating, then Coulomb's law. Congrats. But if it is accelerating, and it is and does have a non-zero distance, then you have this additive term, which to me should be, significant. Has this been seen? Has this been tested? No idea. And again, if I had been more rigorous, I would have looked into how this statement right here. Weber arrived at this result in order to unify electrostatics with electrodynamics. I would have looked into why, if that statement is accurate, and I would have also looked into why it is that Weber's, or Weber, I'm going to call it Weber. Weber sounds cooler. Weber's description of electrostatics was not accepted. My guess is that it's not experimentally verified. Now, if those of you who want to cling to this can actually provide evidence that this formulation has been tested and has been shown to be the accurate form of Coulomb's law, this is in fact how charged particles will move with relation to each other. But there again, this is something else that I'm confused about, because he has thrown out Newton's second law. So what is the force? What is the force? Obviously it's equal to this stuff. Charge, distance, velocity, acceleration, all that kind of good stuff. But what does that actually do to the particle in question? No idea. He then defines this stuff, which seems to mix units, which bugs me, or a bit, not mix units, but he mixes. Oh, see, there's an arrow. Don't see though. Oh, here we go. Now arrow. Like I said, he's kind of up in the air about, or hit or miss as to his notation, and that bugs me. He also seems to what's the word I'm looking for? He's got Newtonian notation. He's got Leibniz notation. Pick a lane. Pick a lane there, buddy. Again, I'm quibbling. The unit vector pointing from is given by this. No shit. That's basic physics. But he comes up with, all right, so, yeah, he's defining what velocity is. He's defining what acceleration is. On page 171, he is doing this. Howdy, Fred. This is my... I feel a little bit guilty in that I'm looking into this, but I've already admitted that I haven't looked into this rigorously. But essentially, these are my initial thoughts looking at this particular chapter. And, this is... And maybe I'm misunderstanding the point of this book, but from what I have gathered is that this is the new textbook. This is a textbook on relational mechanics. The first half of the book, basically, again, it didn't look into it, but presumably, judging from the chapter titles, just covered all of physics, all of the physics that we knew, or know now. And now the author is essentially providing a new theory, a new classical mechanics, as it were. And for some reason, on page 171, he decided, or 170, 171, to go through a derivation of the vector quantities quantity, velocity, and acceleration. I know that may not seem like a whole big deal to those who are not physics inclined, but this is basic shit. This is duh. This says nothing about the conversation. This has no information about relational mechanics as opposed to classical mechanics as opposed to relativity. This, I don't know what this is. A physicist looking at this would be like, why are you wasting my time with this? This is no shit. Although, I take that back. No, I take that back. I take that back. There it is. All right, so his acceleration, going off on that tangent, and I completely missed this, or forgot about this. So, his acceleration term, which really should be, in physics, it should be r hat times the acceleration of the acceleration. Yeah. Nope. The acceleration here is now and these dot products. Guessing those are dot products. All right. So dot products of this times, so interesting. I noticed this before, but I hadn't really noticed. I hadn't really, again, put too much thought from a mathematical standpoint. Because really what physics would tell us is that these two terms shouldn't be there. These two terms are not in classical mechanics. So what this would say is that this is v squared cosine of theta, effectively, where theta is the angle between the two vectors. That would tell us that when the two vectors are perpendicular to each other, this becomes v squared. Yeah, okay. Yeah. Again, no. When you write this is new and different. Again, some description as to, or discussion as to what this is would be nice. He then goes in to define energy as basically this, where he throws in an eta, which is just some kind of constant that he doesn't define, and states here, unlike before, he states in the limit of eta equals 0. I think that's eta. Forgive me if I get my Greek letters wrong, but I'm going to call that eta. I'm pretty sure I'm wrong, but I don't care. Eta equal to 0, c going to infinity. We recover the normal potential energy, gravitational potential energy between two masses. I would have thought, again, that instead of saying c goes to infinity, I would have said as v is much, much less than c. And then the magic happens. Exactly. When v is much, much less than c, then that would go away and give you the normal. That would make more sense to me. But then you take the derivative of this, and now we have that force is equal to this times eta over c squared, with this mess where you have that force of gravity is now proportional to the velocity of the thing and the displacement and the acceleration. So very similar to what we have with up here with classical mechanics, or up here with electrostatics. To avoid the gravitational paradox presented previously, we can utilize the following modifications to these energies. Again, apologies, folks. If I were doing my due diligence, I would have looked up what the gravitational paradox they list earlier, but, I didn't. Howdy, Rachie. How are you doing? More math. Just finished doing math homework. Yeah, sorry. I am going to be ending this soon and going over to Dr. Sun Genesis' book. But here we have the main properties of Weber's potential energy and force as applied to electromagnetism and gravitation are: A, these forces follow the second law, or second postulate, strictly as they obey the law of action and reaction. So, just to catch you up, we have that the author's second postulate is, in fact, Newton's third law, effectively. We recover Coulomb's force and Newton's law of gravitation when there is no motion between the particles, when the velocity and acceleration is equal to zero. This would happen when the distance between the particles is constant, even if they are moving together relative to an arbitrary frame of reference or to other bodies. Okay. But you don't recover them when one object is accelerating relative to the other. That seems to be a problem for me. Or that is a problem for me. C, the most important property is that these energies and forces depend only on the relative distance, radial velocity, radial accelerations between the interacting particles. Although the position, velocity, and acceleration of one particle relative to a frame of reference O may be different from the position, blah, blah, blah. Basically, in other words, these forces and energies are completely relational in their nature. They have the same values for all observers, irrespective of whether the observer is inertial from the Newtonian point of view. This is wrong. Again, I'm being a little salty. If this isn't wrong, please point it out to me in the comments, or yes, I am very technical this morning. Please point this out in the comments or in the chat now. But irrespective of whether the observer is inertial, so these values will be the same whether or not, so whether or not the observer is moving in an accelerated frame or not. Problem I have, I'm still going back to this, is they recover Coulomb's law and Newton's law only if the velocity and acceleration are zero. Which means, the relative velocity and acceleration between the two particles is zero. Okay, so essentially they are at rest relative to each other. So as soon as one of them moves relative to the other, Coulomb's law and Newton's law of gravitation apparently change. Again, this is a prediction. This provides a prediction, a testable prediction. You should be able to quantitatively if you have a system where one object is moving relative to, or one charge is moving relative to another charge. This is much easier done in lab rather than gravitation. You accelerate one object or one charge to another one, and actually, again, there's no prediction here, because I'm going under the assumption that you would have this mess equal to MA. But since MA doesn't exist, I'm confused as to where that plays in. And again, as Norm points out, he seems to be throwing out dynamics, which I'm confused about. All energies and force laws to be proposed in the future must have this property. All masses, all velocities, consequently all forces are relative. All right, great. So he's talking about, at this point I've just kind of given up because there's a lot here. I'm already confused on the basic ideas that they're putting forth. What they're essentially, what I think this is going over is talking about what is the force and energy from a particle as seen from a spherical shell. I think this is going to be some way of coming out, going to Gauss's law, basically saying that you could collapse all the mass to a singular point or all the charge to a singular point. I don't know. Again, this is all derivation stuff. So again, I didn't really want to go into seeing whether or not the math checks out. Implementation of Mach's principle. Here we go. We divide these interactions into two groups. A, the first group defines its interaction with local bodies and with anisotropic distributions of bodies surrounding it. Oh yeah, now I'm starting to remember this. And again, the notation is effed. He defines two things. He defines two situations. Let's see if I can actually find it. Where you have a isotropic distribution of matter. And for those, again, who don't know what an isotropic distribution of, he defines a situation of an isotropic distribution of matter. That basically means that there's more matter over here than over there. Okay. And then I think he defines an isotropic case. We divide the interactions into two groups with anisotropic distributions of bodies surrounding it, the sun and the moon, the matter around the center of our galaxy, the energy of the test mass indicating by all these n bodies can be represented by yada yada. Okay. Oh, I guess this is where he does it. The potential energy is the energy of a test body of gravitational mass mg interacting with body j. All right. Yay. Subscript A means anisotropic. Force exerted on. Yep. Got it. Sum of the forces. Got it. Good job. Second group is the interaction of the test body with isotropic distributions of bodies surrounding it. Okay, that means that it's an even distribution of stuff. Technical term. Biisotropic means bodies are spherically symmetric. La, 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 la. Isotropic, big I. We now utilize the known fact that the universe is remarkably isotropic when measured by the integrated X-ray and microwave backgrounds or by radio source counts and deep galaxy counts. It should be observed that we are not assuming this fact to be truly theoretically. Oh, all right. They're not postulating that the universe is isotropic from basically first principles. They are doing this because it is observationally shown to be such. Which, funny enough, one of the things that particularly space audits likes to accuse relativity of is reverse engineering. This is kind of when I think of reverse engineering, this is kind of what I'm thinking of, is there's a difference between an empirical law and a derived or basically first principle law. Kepler's laws, for example, are empirically derived. They are based on empirical evidence, whereas Newton's laws are derived from concepts of the idea of the concept of inertia, the concept of gravity. They are not based on they are not based on data. Their formulation is not based on data. What is done is that the formulation is derived or created, and then you see whether or not you are correct by comparing it to observed data. Because they are basically specifying that, things are isotropic because we see them as such, and presumably this is going to be a stepping stone or foundation stone for relational mechanics. That's a problem. That is reverse engineering. As the Earth does not occupy a central position with respect to the universe, interesting. That seems to really kind of go against the whole flat Earth notion. Isotropy on large scale suggests homogeneity. Here's another place where he drives me to drink. Rho g is equal to rho naught equals constant. Rho g is the gravitational density. Rho naught? Don't know. He doesn't define that until three paragraphs later. Due to the great distances between galaxies and their charge neutrality, they can only interact significantly by any distant body through gravitation. We can now integrate blah, utilized to get a constant matter density. That is rho g, which again he doesn't specify, but you have to infer based on what he's talking about. In this way, we obtain the isotropic energy between two masses. In other words, the isotropic and homogeneous distribution of galaxies, which is rotating with an angular velocity relative to the frame S. We replace omega blah blah blah, and because we integrated the mass dm of the shell over the whole universe, indicating the mass of the universe by U. Again, this may be a fundamental misunderstanding that I'm having, but he is defining omega as the angular velocity relative to a frame of reference S, an outside frame of reference. And so he is measuring the universe's angular momentum to an outside frame of reference. Again, this could be a misunderstanding on my part, and if someone can correct me on this, I would very much like a correction. But that's not done. That is nonsensical. You cannot have a reference frame outside of the universe. The universe itself is reality. All of reality. So there is no outside of the universe. So how is there a reference frame outside of the universe? Yeah. Again, me not know. The other issue, and I think this is where I kind of dozed off, is... and then he goes into essentially looking at Einstein's field equations, or something equivalent to it. God's reference frame, possibly. I would certainly think that Mr. Kirkin would think so. That's a reference to the survival guide that I talked about on a stream a couple days ago. And I know that he goes further on later in the book, and he talks about talks about springs and so forth, applications of relational mechanics, uniform rectilinear motion, yada yada, constant force, all this. And if I had, I see. Yeah, all right. Where Free fall, okay. He defines this by his earlier, basically, field equation kind of thing. I don't know. You have inertial attraction. That seems to be conflict. I don't know. All right, I need to stop because, yeah, I haven't looked into this. There are certain principles that maybe I'm just dense. I just don't seem to understand until I understand those basic principles. I really don't see much hope of me understanding anything else. Oh, excuse me. And so, yeah, that's where I basically stopped. Is the thing that I noted was, again, if I were from a teaching standpoint, or really any book on mechanics that I have ever seen, is you take it from first principles and move up. So you define such things as velocity, acceleration, so forth. You define what a force is. You then talk about, kinematics, ballistic motion, or not even ballistic motion. You just start off with, you have a particle. You apply, you have a particle. It accelerates by some amount. By some amount over t. What is its velocity at the end? Talking about the motions of things in very simplistic first order kind of ways. Not this. He just immediately jumps into looking at how things move in the universe. Yeah, okay. Which is why I think I'm having such a disconnect, because he's fundamentally changing two things about physics in a way that, again, I just don't get and don't really have the motivation to go into. Is he gets rid of inertia. Inertial mass isn't a thing. So F equals A is not a thing. He also states that the sum of all forces in all frames is zero. Again, these are huge, huge things. Fundamentally just brown or like altering things. The example that I would give is, this is akin to the idea that force is communicated via or gravity is a force communicated by a carrier particle to gravity is in fact due to the curvature of space-time. That's the kind of fundamental difference that I'm talking about. And just kind of glosses over it. And so, yeah. Let's consider motions over the Earth's surface and in the solar system. No, how about we discuss, throwing a rock? How about we do that? That would be nice. Consider the motions of blah, 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 such that we neglect the acceleration of the solar system relative to the frame of distant galaxies. Okay, sure. Moreover, as the mass of the sun is much greater than the mass of the planets, we can, in first approximation, disregard the motion of the sun relative to the fixed stars due to the gravitation attraction of the other stars as compared with the motion of the planets relative to the stars. Let's see what he's going with this. We can then say that the sun is essentially at rest relative to the fixed stars, while the Earth and other planets move relative to them. Here's a problem, is that, yes, to first order. To first order. However, if you look at the mass of the solar system, 99.9% of the mass of the solar system is in fact locked up in the sun. 0.1 is locked up in Jupiter. This is not exactly negligible. So, this statement here that we can say that the sun is essentially at rest relative to the fixed stars while the Earth and other planets move relative to them. Yes, but with any kind of precise measurements, this doesn't hold anymore. We first consider the Copernican worldview, which is usually seen as being proved to be true by Galileo and Newton. Here we consider the sun in the center of the universe, while the earth and blah, blah, blah. To simplify the analysis, we consider only circular orbits. Sure. Let's just simplify it to circular orbits. Let's ignore the whole elliptical orbits, precession of orbits, that sort of thing. Let's just, not think about that. Relational mechanics can be applied here with astounding success. Despite the gravitational attraction between the sun and the planets, the Earth and other planets do not fall into the sun because they have an acceleration relative to the fixed stars. Distant matter in the universe exerts a force negative mg a blah blah blah. This would be a of the m. I don't remember what. I'm sure he defines that. So the distant matter of the universe exerts a force of that on an accelerated planets, keeping them in their annual orbits. The rotation of the Earth around its axis relative to the fixed stars explains its oblate form, with a similar distance between the poles than at the equator between east and west. Foucault's pendulum is explained by noting that the plane of oscillation remains fixed relative to the fixed stars. Okay. This I can say definitively is bullshit. So, what this is stating is that the reason why the stars, or the reason why the planets, let me calm down a bit, the reason why the planets stay in stable orbits around the sun is not because of, apparently, not because of the gravitational attraction that they feel due to the sun, excuse me, but rather based on both that and the force of the universe, essentially, on those orbits. The distant matter in the universe exerts a force of that on accelerated planets, keeping them in their annual orbits. So, this is definitively stating that the matter of the universe is what is keeping the planets in line. That if we do not account for the force of, or the distant matter in the universe, then we cannot accurately measure the orbits. Immediately, two things. Rachel, yes, that's wrong. One, this mg, what's that mass? Is that the mass of the planet? Or I would think that would be the mass of the universe. How do you derive that? Or is this suggesting that if you know the orbits very well, and you know what the gravitational attraction between the Earth and the Sun is, then you can derive the mass of the universe based on what's discrepant? Because again, because if you remember, the third postulate is that the sum of all forces is equal to zero, regardless. So if you look at the Earth going around, let's say Jupiter, it's the biggest one. You have Jupiter going around. No, let's go back to the Earth because, Earth, geocentric, all that kind of good stuff. You have the Earth going around, all right? All things being equal in classical mechanics, the Earth is being accelerated. The acceleration of the Earth is non-zero, but apparently that can't happen with relational mechanics or in relational mechanics. So he's stating that there has to be a another force that is offsetting the acceleration that the Earth feels due to the sun's presence. So yes, I would imagine greater minds than I would be able to determine the mass of the distant matter based on observations of the Earth going around the sun. That ain't possible, as far as I'm aware. No one's done that, as far as I'm aware. The rotation of the Earth around its axis relative to the fixed stars explains its oblate form. No, it doesn't. With a smaller distance between the poles and at the equator between east and west. You can't just state that. Because, again, that is not in evidence, as far as I know. Again, I missed a few things, so maybe he explains that later on. But the oblate form, again, is due to centrifugal force. It's due to it's due to non-inertial forces, which aren't a thing because inertial forces aren't a thing. Foucault's pendulum is explained by noting that the plane of oscillation remains fixed by whatever. Okay. In the Ptolemaic system, the Earth is considered to be at rest without rotation and the center of the universe, while the Sun, other planets, and other stars rotate around the Earth. In relational mechanics, this rotation of distant matter yields the force such that the equation of motion takes the form of that. Howdy, Blue. Now the force, gravitational attraction of the sun is balanced by real gravitational, as opposed to fake, gravitational centrifugal force due to the annual rotation of different masses around the Earth, with a component having a period of 1 year. In this way, the Earth can remain at rest and at an essentially constant distance from the sun. Again, it's not at a constant distance. To first order it is, but it ain't. The diurnal rotation of distant masses around the Earth with a period of 1 day yields a real gravitational centrifugal force flattening the Earth at the poles. Foucault's pendulum is explained by a real Coriolis effect acting on the moving masses over the Earth's surface by the form yada yada. With the velocity of the test body relative to the Earth, and omega is the angular rotation of the distant masses around the Earth. This is the angular rotation of the universe, for those who are keeping score. The effect of this force is to keep the plane of oscillation of the pendulum rotating together with the fixed stars. Okay. As a matter of fact, any other frame of reference would be equally valid. Anyone or any arbitrary frame of reference can be considered at rest while the entire universe moves relative to this person according to his will. This happens not only kinematically, as we have seen, as has always been known, but also dynamically. I wonder where Austin gets his catchphrase that this is kinematically and dynamically equivalent. Could it be from here? All local forces acting on the person will be balanced by the force exerted by the rest of the universe in such a way that the acceleration and velocity of the person will always be zero. Again, this smacks me of reverse engineering. Because essentially what you're saying is that the mass of the universe is exactly equal to what it needs to be in order to observe what we have. Right. For instance, consider a rock falling freely to the earth due to its weight. In the frame of the rock, it will always remain at rest while the earth and the universe are accelerated upwards. This happens in such a way that the gravitational force exerted on the earth by the rock is balanced by the gravitational force exerted by distant masses on the rock, yada yada. Relational mechanics implies quantitatively and dynamically the old objective of making all frames of reference equally valid and correct. The form of the force exerted by distant masses on a test body may be different in different frames of reference, but not the value or direction of this force relative to other masses. It may be more practical, simple, or mathematically convenient to consider one frame of reference as preferred relative to others, but as a matter of fact, all of them yield the same results. The important consequence of relational mechanics is that kinematically equivalent motions have been shown to be dynamically equivalent. Again, I missed that. Regardless of whether you say that the stars and galaxies are at rest while the sun or the Earth rotates around its axis with a period of 1 day, yada yada yada. All right, I'm gonna. The Earth was relative accelerating upward. Yeah, Rachie, we still need to have a conversation as to where you are, where you are currently in terms of. I've heard that you're a baller. Fucking hate that term. I've heard that you have now accepted that the Earth is a sphere and all that kind of good stuff. But I am curious to know. The last I heard was that before then, you were thinking about the Flat Earth Society of the Earth still being flat but accelerating upward at 9.8 meters per second squared. But let's put that aside for a second. All right. So, in this text, and again, I skipped quite a lot of the derivation. But I don't think it answers the problems I'm putting forth. In this, he makes the assertion that, one, he assumes circular orbits. It's not the case. It's not for Mercury. It's not even close to being the case. And two, and actually this one is more important, is that he assumes that the total mass, that the entirety of the mass of the solar system is in the sun. He uses words like essentially or practically, or he uses qualifying terms, but he states them in such a way as that effectively the second order terms, as it were, can be ignored. Well, no. If you're going to talk about how things move in an absolute sense, in predicting how things are going to move in the future, if you're going to be truly predictive, you cannot simply ignore second order effects, such as the mass of Jupiter. The other problem with this analysis is that, again, he seems to imply that you can know the mass of the universe based on the motions of things relative to each other, because, as stated, the reason why the Earth is held in its orbit around the sun is not just because of the gravitational attraction due to the Earth, or due to the sun, but also the counteracting gravitational attraction due to the rest of the friggin' universe. Yeah, okay. So, let me, for once and for all, and, you can clip this, you can send it to whoever. Professor Park's PhD does not believe that relational mechanics is dynamically and kinematically equivalent to classical mechanics or general relativity. From what I've seen so far, there are certain fundamental problems with this idea that this author, at the least, does not explain very well. That could very well be the author's fault, and so if there is another work that explains it better, If I had more time, I would look into it. But right now, I am not even convinced. No. No, 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 no. Yes. So, but yeah, I would say that it's a complete crock of shit at this point, Cygnus. But as has been noted by others, Toon for one, I think Blue has mentioned this, is that when we look at this from how it's being used within the flat Earth community, particularly by Austin Witsit and his camp, because Oakley disavows this completely, and I don't think Jeranism is really on board with this either. Is that relational mechanics, at its core, states that agrees with the cosmological principle in that there is no preferred point in the universe. Yes, you can state that the Earth is in fact the center of the universe, or not. And I think this is where we're going to go with Dr. Sun Genesis, because Dr. Sun Genesis goes further. If I remember his book correctly, or the book is entitled Galileo is Wrong, is that he states definitively that the Earth has to be the center of the universe. This actually states quite clearly that no, that is not the case. That the Earth is in fact just like any other point in the universe. Which, to first order, again, when I was thinking about this from a naive standpoint, and then yes, I would agree with that in the sense that, yeah, motion is relative to each other. You cannot tell if one thing is one thing is absolutely fixed and the other thing is moving. You cannot tell. You cannot state that as according to relativity. Great. They relational mechanics seems to double down on this. Really what relativity was attempting to state was that there is no absolute reference frame. From this standpoint, reference frames, you don't need to consider them anymore. Reference frames are not a part of physics anymore, apparently. Yeah, I'm done with this. I was going to go over these points. Fuck it, I'll go over these points. 1, the inertia of a body must increase. All right. In section blah, that in 1922, Einstein pointed out 4 requirements which should be present in any theory incorporating Mach's principle. The inertia of a body must increase when ponderable masses are accumulated in its neighborhood. 2, a body must experience an accelerating force when neighboring masses are accelerated, and in fact the force must be in the same direction as that acceleration. A rotating hollow body must generate inside of itself a Coriolis field, which deflects moving bodies in the sense of the rotation, and a radial centrifugal field as well. A body in an otherwise empty universe should have no inertia. Related to this is a statement that all the inertia of any body should arise from its interaction with other masses in the universe. Okay. Apparently, we have not seen this implemented in Einstein's general relativity, so he basically is attempting to use Einstein's critiques of Mach's principle to himself. Where have I seen this before? Yeah, all right. He goes into that. Oh, you can't see that. I'm not sharing my screen. All right, let's go into. But the take-home point that I want to make with this, to be very clear, is that the flat Earth model, as in the simplest way possible, I think in this way, I can't even say that, which honestly is is a problem. The fact that I cannot definitively state that that the flat Earth community agrees on anything is a problem. So, but what I was going to state was that the flat Earth community would agree that the Earth is a preferential point in the universe, that everything revolves around the universe. And I think we can still state that. Because there are those if I remember correctly, there are those that believe that the Earth is in fact an infinite plane, that the Earth as we see it is but one of many Earths in a infinite plane or what have you. But the stars that we see, the universe that we experience, revolves around it. So, yeah. This is stating relational mechanics doesn't work in that relate. It freely admits that by its nature, any point in space is preferential. So, when you are attempting to use this to put forward your idea of this supports flat Earth, no, it doesn't. It doesn't support flat Earth, and even if it could replace general relativity, you still have the problem that the Earth is not by nature, by absolute nature, the center of the universe. It's not. I know that Austin has said at times that he doesn't buy into all of relational mechanics. You know what that is? That is the literal definition of cherry picking. The idea that you take a theory, you take the bits of it that you like, and you ignore the rest of it. That's not how science works. Science, you cannot simply cherry pick the parts of a scientific theory that you agree with and disregard the rest. The theory is comprehensive. You can't take one part as separate from another. They are interconnected. And when I say parts, what I mean is specific fundamental properties of a theory. So in this case, the fundamental property of the theory is that motion is relative to the two bodies, and that's it. So you can state that the Earth is in fact the center of the solar system. The Earth is the center of the universe. You can't take that without the accompanying statement that you can take any other place in the universe as the center of the universe. That's not how this works. That's not how science is done. You cannot cherry pick. Even if you have an independent variable and a dependent variable, the scientific method states that this is not possible, that you cannot do this. So, yeah. All right. Getting angry. All right. No, that's not what I want. All right. Oh, I have a folder that I call Quack Science. One of them, and so I'm trying to look through. Let me see here. Galileo is wrong. You know what I can do? Let's go to Discord. Let's go to Eric E, because I'm pretty sure Eric sent it to me initially. So, you're egocentric. All right. Galileo. Let's just search for that word. There it is. Visit site. Loading, loading, loading. All right. Volume 1, 12th. Holy crud. Holy crow. This is he made 12 editions of this? That's a lot. Not even science, like college textbooks, which is a racket, by the way. You can quote me on that. This is 6th edition, and this has been out for a decade or so. 12 editions? Jesus. Who's he trying to sucker money out of? Sorry, folks. I can't seem to find it on my hard drive, so I've been downloading, or I'm downloading it off the site, or downloading it again. And Luna, what are you doing? Oh, really? You're just gonna sit on my keyboard? Is that how it is? Yeah, you're just gonna sit there? Not like I'm streaming or anything. Not like, I might need the keyboard. Are you trying to tell me that I shouldn't even look at this? That Galileo was in fact right and this is just a bogus thing? Is that what you're trying to tell me? Or are you trying to tell me, stupid human, pay attention to me, I want love? All right. I think that's what's happening. All right. Luna, I am doing this in the name of science. Yeah. I knew she was going to be hungry. All right, so cat break. Meow, 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 meow. Yeah. Meow, 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 meow. You're going to hate me. You hate me right now, don't you? Yes, you do. You hate me. Oh, no. Okay. Figure if I irritate her enough that she won't pop back up here. Yeah, Norm, I'm the same. I have kept all of my textbooks, and even though I basically can look at all of it online. Oh, nope. She's back. Okay, hold on. Let's see here. Let's see what you made me do. Nope. Ow! Don't chew on me. All right. Where am I going with this? Google. There we go. Galileo was wrong. The church was right. Dun, dun, dun. You know what? I don't think I've ever. The church is right. Yeah. I don't. That's how I feel about the church right now. Not gonna do that. Ooh, look! I missed this. It's dedicated to Al. That's cool. Orion said, who invented special relativity to counter experiments that revealed the Earth was motionless in space, which then led him to general relativity that forced him to accept a motionless Earth at the center of the universe as a viable and worthy cosmological system. What? Okay. Sorry, I'm just going off the rails at this point. What? The fuck you say? Einstein, who invented special relativity to counter experiments that revealed the Earth was motionless in space. No. They revealed that the Earth was motionless to a semi-luminous ether, not space, which then led him to general relativity that forced him to accept a motionless Earth in the center of the universe as a viable and worthy cosmological system. Einstein never, ever was a geocentrist. Where are you getting this? No friggin' idea. You gotta be... what? You gotta be kidding me with this. Also, I don't think that's how the relativity was developed. I could be wrong. I haven't studied the history of how relativity came into being. That's actually one of the things I would like to devote my attention to, is actually looking at the history of how how the theory of relativity came about. From my understanding, they were co-developed, and that the special relativity was published first as a way of providing a framework from which general relativity could be understood. I very well could be wrong there, but that is my understanding of how it works. And Cygnus, if my hair were white, I would definitely be able to pass for CC at this point. All right. Oh, Robert Bennett holds a doctorate in physics from Stevens Institute of Technology with a thesis on general relativity entitled Relativistic Rigid Body Motion. Rock on. Chapter 10 was written by Dr. Bennett. Endorsements. Gerardus Bowell, PhD, Case Western Astronomy. Gonna need to look that person up. Vincent Schmidt, PhD, Physics. This book shatters the mythology of the modern mind. Galileo and Einstein go the way of Zeus as the truth ascends to reclaim man's destiny. It will change the world more dramatically than Copernicus, Galileo, Kepler, Newton, and Einstein combined. Remember, Kirkin, truthers are humble. Dr. Jones, Physics, Imperial College London. Hey, we got a Brit. PhD History, don't care. Aerospace Engineer, don't care. NRO. Wow, I'm really going to have to look these people up. Arntz, I actually looked up because I was at LSU, so in chemistry, and I think they're old. That's all I can remember. Philosophy, don't care. The Kalsigan Foundation, don't care. Anonymous PhD from MIT. Sorry, but if it's anonymous, you can't use them as a reference. Medical doctor, I think. No, Master of Education, MIS. I don't know what an MIS is. I'm looking at medical college. Yeah, I don't know what an MLS. I have no idea. Doman, MIT. The very mention that the Earth is motionless at the center of the universe, with the sun and universe revolving around it each day, as outlined, defended from physics and astronomy in this book, elicits a profound initial disbelieving shock. That's an understatement. This is not a matter of belief, but of evidence and of demanding study. Hello, Sonny. Accumulated evidence justifies the rational claim of the text. All right. Yay, quotes. Stephen Hawking, Eddington. More quotes. Einstein himself once admitted reliance on the doctrine of Copernicus is not nearly as strong as we were once led to believe. Since the time of Copernicus, we have known that the Earth rotates on its axis and moves around the Earth, or around the Sun. Excuse me. Even this simple idea, so clear to everyone, was not left unnoticed by the advance of science. But let us leave this question for the time being and accept Copernicus's point of view. Let me read that again. Since the time of Copernicus, we have known that the Earth rotates on its axis and moves around the Sun. Even this simple idea, so clear to everyone, was not left untouched by the advance of science. But let us leave this question for the time being and accept Copernicus's point of view. Okay. I don't know what that really says. Hawking. So, which is real, the Ptolemaic or the Copernican system? Although it is not uncommon for people to say that Copernicus proved Ptolemy wrong, that is not true. Correct. That is not true. As in the case of our normal view versus that of a goldfish, one can use either picture as a model of the universe, for our observations of the heavens can be explained by assuming either the Earth or the Sun to be at rest. Yeah, I would need to see more context for that. But what I can tell you is that the Copernican system, as the system Copernicus developed, with circular orbits and epicycles, was not any more predictive in it, or was not any more accurate in its predictive capability than the Ptolemaic model. The Copernican model had two things going for it that the Ptolemaic model couldn't. The Copernican model, could tell you relative distance. So if you knew the distance between the Earth and the Sun, you now can actually determine an absolute distance between the Sun and Mars, or the Sun and Venus, or the Sun and Jupiter. He was kind of okay with that. Saturn, not so much. There was he was kind of off on that one. But the rest of them, Mercury, Venus, Mars, and the inner planets, and Mars, the ratio of distances is remarkably on point. It's accurate to 1 part in 1,000. For a dude in the 1500s, that's saying something. But the second one is that the Copernican model was simpler to use from a mathematical standpoint. And Occam's razor tell us that if you have two models that are equally predictive or work just as well, you need to take the simpler one. The simpler one is the better explanation, which is why people move forward with it. Modern science has indeed been very happy to follow Einstein's prescription to accept Copernicus' point of view, even though it has been made very clear by the advance of science has revealed is unprovable assumption. No, citation needed. Yeah, okay. More quotations. James Coleman, the easiest explanation was that the Earth is fixed in the ether and that everything else in the universe moved with respect to the Earth in the ether. Such an idea was not considered seriously, since it would mean, in effect, that our Earth occupied the omnipotent position in the universe with all the other heavenly bodies paying homage by moving around it. No, that is not why it was rejected. It was rejected because the idea was, and yes, this is true, with the Earth moving around, the Michelson-Morley experiment could be explained that, well, at its core, it was a null result. One of those explanations is, and what it attempted to do was it attempted to determine the velocity of the Earth relative to the ether. So there are three ways you can go about this. You can assume that the Earth is stationary. In that sense, yes, that was rejected outright because it would violate the Copernican principle. Two, that the ether is motionless with respect to the Earth, meaning that the Earth moves around the sun with the ether. And 2, that the ether ain't a thing. Well, and I think we have Mach to thank for that one. The problem with the ether moving with the Earth is something known as frame dragging, is that the Earth is literally moving the frame of the ether around. What that's going to cause is that's going to cause energy loss. There is energy loss inherent in that situation, and therefore what we would expect is that the Earth's orbit would decay. That is why it was rejected, not because of the Copernican principle. Lincoln Barnett says much the same thing. Michelson-Morley experiment confronted scientists with an embarrassing alternative. On the one hand, they could scrap the ether theory, which had explained so many things about electricity, magnetism, and light. I wouldn't go so far as to say explain so many things, but okay. Or if they insisted on retaining the ether, they had to abandon the still more venerable Copernican theory that the Earth is in motion. To many physicists, it seems almost easier to believe that the Earth stood still than that waves could exist without a medium to sustain them. It was a serious dilemma, one that split scientific thought for a quarter century. Many new hypotheses were blah, blah, blah. The experiment was tried again. Same conclusion. Again, this seems to imply that the Copernican principle was ever in doubt. From what I know, by scientists, by people like Lorentz, people like Mach, this was never considered at all. This was not in contention in any way. All right, let's get through this. Oh, yay. What's a good heliocentric model without a biblical quote? And not just a biblical quote, a full-on biblical passage. All right, yay. More quotes. All right, for those of you out there, and I did a short on this. For those of you out there who are truthers, for those of you out there who are science skeptics, and I've been dismissive, and I don't mean to be dismissive. I'm just frustrated, and like I said, 2 hours sleep. So this is, I hope you take this with as earnestly as I can, and if you are looking into identifying what is true and what is not true, a huge red flag, in my estimation, is quote mining. If you see a book or website or whatever where a good chunk of its introduction is quote mining, then don't trust that source. Because what they're attempting to do is they're attempting to use the quotes by Albert Einstein, Pauli, Poincare, and so forth, taken out of context, to put in your mind that even these great scientists thought that this was true, or entertain the idea that this may be true. That is wrong. Like, for instance, briefly, everything occurs as if the Earth were at rest, ... It would be very interesting to know what the rest of that ... means. Because the next word could very well have been but. Oh, zoom, full page. Sorry. There we go. So, if you see a text or a book or what have you, oops. Where did I'm trying to find? I don't know how many people are watching. I must know how many people are watching. Anyway, if you find a book or any kind of source where it is basically talking about, where it attempts to justify its own point of view by taking quotes out of context from notable personnel, notable experts in the area, distrust it. Distrust it. Because this is a manipulative, false tactic. I'm not going to mince words here. This is deceptive, and I think it's deliberately so. Raichi, paper 1924, considering the ether. Einstein said the ether of general relativity is not absolute because matter is influenced by the ether just as matter influences the structure of the ether. Sorry, Dr. Bob. I do remember him saying that, and yeah, exactly. The thing is, I would need to reread that paper because I think there might be, and again, could be very wrong, is that his definition of ether, I don't believe is the definition that was currently being bandied about. I think his words were poetic. I don't know. But I've seen that quote again being used as a justification that Einstein was in favor of the ether, which he was not. Hell, that paper may in fact be cited in here. More quotes. Chapter 1. New Galileo and the truth about Copernicus. Galileo was wrong. How could modern men from blah, blah, blah. Typical remarks in a book about Galileo. Stern, blah. Galileo, who produced the irrefutable proofs of the sun-centered system, came into direct and disastrous conflict with the church. Who better than Galileo to propound the most stunning reversal in perception ever to have jarred intelligent thought? We are not the center of the universe. The immobility of our world is an illusion. We spin, we speed through space, we circle the sun. We live on a wandering star. No, we don't live on a wandering star. We live on a planet that is orbiting a wandering star. But anyway. And not for nothing, the reason why Galileo got into some shit is because of his dialogues. And not because of what was said in the dialogues, but because he referred to the interlocker of the geocentric theory or idea as stupido. Basically, he was calling the Pope an idiot. Probably shouldn't do that. Probably should not do that. That's really what got him into some shit. Even still, they put his ass under house arrest. They didn't burn him. Blah, blah, blah. I'm not getting into this because I don't care. This seems to be, I'm going to guess, is going to be some kind of misconstrued. Yes. Also, Cygnus. Again, because I don't like NDT, and again, if he ever watches my stuff and I ever meet him, it's going to be super awkward. Bruno was not burned alive solely because he believed in exoplanets, or he postulated the existence of exoplanets. He was burned for 8 reasons. The number 1 reason is that he denied the divinity of Christ. That is what got him burned. He didn't really care about exoplanets. He's not some martyr to science. He refuted the divinity of God. That's what the church actually gave a shit about. So, yeah, this whole martyr to science bullshit, I really, really wish people would get off that. All right. Whatever. I thought this book had... Yeah, this is all just quote mines. I thought I had read this. And he actually put forward... Maybe that's chapter 10. Let's try that. Kepler's eclipse as an epicycle. All right, interesting. Maybe... Evidence Earth is the center of the universe. Correlation between SMB. Blah, blah, blah. Wait a minute. Didn't he say chapter 10? Oh, crud. Sorry, folks. I could have sworn when I looked through this, I actually saw him talk about math. There was something in particular that I wanted to address. And I'm guessing, if anyone can remember, if everyone saw it. No, see, Dr. Bob, I thought it did. I thought there was actually an analytical analysis within this book, because I've read analytical analysis in this context. Maybe it's about the. And I thought I remember just reading that one of these chapters was written by Bennett. All right. Dr. Bennett has written Chapter 10, a detailed and technical mathematical explanation of the various arguments for geocentrism. That's what I want to look at. Chapter 10. And that's what I've looked at in the past, but it's been a very long time since I've looked at it. But forgive me in that this is Chapter 3, Chapter 6, and the book ends. Or there is no Chapter 10. Okay. Maybe it's this one. All right, let's go to 107. I think it's that one, yeah. All right. Chapter 1. What? Oh, this is still. Ptolemy, blah, blah, blah. First, yep. Brahe, yep. Kepler, yep. Speed of light, yep. Okay, Ellis, yep. Modern science, Copernican principle. Actually, yes, but more specifically the cosmological one. But hey. Okay, I don't know what all that is about. Oh, I should have realized it was much further down. Line. Study notes? Study notes. Yeah, nice. More. Quote mining! Stop it! Stop it! Bad book. Bad book. Phil, I always mispronounce his name. This is bad astronomy, dude. Really cool guy. I have two things to say that might surprise you. First, geocentrism is a valid frame of reference, and second, heliocentrism is not any more or less correct. Ish, yes, in the sense that the cosmological principle, again, I will beat this like a dead horse, a dead red-headed reptile horse, is that the Copernicus principle states that there is no preferential position in the universe. It is just as valid to say the Earth is fixed. It is just as valid to say the Mars is fixed. It's just as valid to say anything else is fixed. This is what I'm talking about. To use this quote to somehow back up the point that geocentrism is actually correct is deceptive. It's an outright lie. This is just not acceptable. I have not had the honor of meeting Phil, but I'm pretty positive that if I were to ask Phil, hey, how do you feel about one of your quotes being put as an argument for geocentrism, I think he'd be pretty irritated. I don't know about that. We are unreconstructed geocentrists hiding behind a Copernican veneer. Again, I would like to know the context of that, because I would suspect that he is talking about that humanity has still yet to let go of the anthropic principle that a good number of people still hold true that the humanity has a special physical preference or position in space. Because look at the title. A universe not made for us. That to me would indicate that what he was saying is that the universe was not made for us. That we are not here. The universe is not here because of us. It is here regardless. So again, deeply deceptive. All right. Doesn't the smaller body always revolve around the larger body? No, actually, not. They revolve around a barycenter. The larger body and the smaller body all revolve around a point, which is the center of mass of the system. So, that center of mass may or may not be inside one of the bodies. So, geocentrism doesn't state this. Or, modern science doesn't state that. That would not be an objection. So, that's straw manning. Hoyle. Blah, blah, blah. Yeah, I'm not looking into that because it's a straw man, and I don't, I'm not going to fucking deal with it. Hey, look, center of mass. There you go. All right. Newton allows for a geocentric universe. Although Newton sought to apply his laws of motion only to the solar system, so that, as he says in his 1684 Scholium, hence, indeed, the Copernican system is proved a priori. For if a common center of gravity is computed for any position of the planets, it either lies in the body of the sun or will always be very near it. Okay, yep. It's true, Huygens? Actually, it was Haley, but go nuts for those cronuts. Haley, the guy who, discovered the planet, or discovered the comet, he was the one who actually got Newton to get off his ass and actually publish his Principia. Don't care. Hey, look! It's the book I was just reading about. Oh, look! We were just looking at that equation. Hey, it's all full circle. Coriolis effect. Yeah. See, I don't want a straw man. There's one particular thing. Popov. the fucking gall. To quote Popov. I think Karl Popov, who is talked about is one of the basically fathers of the modern scientific method. If one could put the whole universe in accelerated motion around the Earth, the pseudo-potential corresponding to pseudo-force will immediately be generated. That same pseudo-potential causes the universe to stay in that very state of motion without any need of exterior forces acting on it. Okay. Center of mass of the universe. Interesting. Okay, I may just have to go on my memory and may have to potentially strawman. Two-body problem. Sweet. Yep. there was, all right, so, and again, I'm going to go off on a limb, and again, I could be a straw man because I cannot seem to find the section that I found, or that I read before. I should have notated it somewhere. Is that somewhere in here, I believe it's in this text, but it's definitely in one of these texts, is that as I've stated before, relational mechanics agrees with general relativity that relative motion is, well, relative. It is equally valid to say one thing is moving with respect to another as the opposite. The problem comes in that, or the step that this person takes. Doesn't stellar parallax prove the Earth is moving? Is that, until proven otherwise, I am just going to state that it's in this text, is that Sun Genesis states that by the argument of center of mass, that the Earth must in fact be the center of the universe. Okay. The problem, again, and I really wish I had the text so I could dissect it more. I need to calm down. Is I don't remember exactly what his justification for it. I just remember that point, that he stated that the Earth must, not can, but must be the center of mass of the universe. The problem I have with that, or the questions I have with that, are, and I hope I'm not making people sick by scrolling so quickly, is what happened before the universe? Sorry. What happened before Earth? Because again, relational mechanics tells us that everything in the universe is as we would expect it, meaning Big Bang is real, the universe is 13.7 billion years old, so forth and so on. Relational mechanics doesn't refute that. This whole argument is based on, the underpinnings of this is based on relational mechanics. So the question then becomes, are you assuming that the universe came into existence from the Earth, that there was nothing prior to the creation of the Earth? I don't know if Sun Genesis is a young Earth creationist. That would be a question that I would love to have for them. But when I was looking through this is what I was talking about in terms of when I first looked at this, when I just gave it a cursory glance, that this was, that sure, maybe it's equivalent, is that all of this, yeah, this is all just going over the same principle that, in fact, you cannot tell what is moving with respect to the other. When you look at the orbits of two objects moving around each other, it is very common to take one of those objects, usually the most massive or most luminous, and consider it to be fixed. And then you plot the orbit around it. Is that what's actually happening? No. If you were in the Starship Enterprise, out as a independent frame of reference, and you were looking at this system, what you would notice is that both stars are moving with respect to each other. But if you are on that star, you could consider yourself to be fixed, and you would see that star, the companion star, moving around. If you're on the companion star, you can consider the companion star to be fixed, and you would see that other star moving around you. This is essentially what is meant by Einstein's often misquoted quote, where you cannot optically, there is no optical experiment to verify that this Earth is moving with respect to the sun in an absolute sense. That's paraphrased. That is what he means by that by that quotation is that it is impossible to determine in an absolute sense what is moving relative to the other, because that doesn't make any sense anymore. That would imply an absolute frame of reference. So all of this is just that same principle over and over and over again. Stellar aberration, yep. Aberration of the sun. Speed of light. All right, this one. There is one other factor to consider: the speed of light and difference between the source and the receiver of the starlight. Modern heliocentrism believes A, starlight is independent from the star once it is emitted from the star. Yes. B, the emitted starlight is not independent of the motion of the receiver. Come say what? No, it is independent. It's independent of both. If I understand what he means by independent, in that the motion of once a photon is emitted from a source, it is no longer physically attached to it. If you change the source in any way, the photon doesn't care. It doesn't respond to that change. In that sense also, if you have the receiver, if the receiver changes in some way since the emission of that photon, again, the photon doesn't care. Maybe I'm being too literal here. I think what they're getting at is, in the sense that it's not independent, the motion of the observer is going to see the photon differently. All right. All right. Photon, whatever. Foucault pendulum. Don't care. Ether. Bulge at the equator. Geocentric satellites. I know this is not overly exciting. I'm really trying to find where he states this, and I could be very wrong. Again, I apologize for not being prepared for this. Does star streaming prove the Earth is moving? Star streaming is the optical phenomenon occurring when stars seem either to spread apart from one another or moving closer together. Okay. Doesn't the Doppler effect prove the Earth is moving? No, it just proves that two things are moving relative to each other. Isn't the geometry of geocentrism more complicated than heliocentrism? Only if you stick to the original Aristotelian prescription that everything moves at the same velocity and everything moves in perfect circles. Then, yes. What does he have to say? A somewhat common objection to geocentrism is that if it were true, the whole geometry of the solar system would be out of whack. Planets would be revolving in different orbits. Nothing would look the same, blah, blah. Some even believe that planets and asteroids would crash into each other. Who believes that? So I should say all these objections have no merit. That the geometry, distances, and speeds are identical between the Copernican and Tychonic systems, yes, you would have to assume the orbits are exactly okay. In the geocentric system, why do planets revolve around the sun instead of the Earth? Because you're reverse engineering it that way. Tycho, who came up with this idea, was basically splitting the difference. He didn't want to irritate people by saying that the Earth was moving around the sun like Copernicus did, but he realized that Copernicus was kind of right in that the observations seemed to show that the Ptolemaic system was flawed. So, blah. Doesn't the four seasons prove the Earth is tilted? No. The sun could be tilted towards the sun. Okay, whatever. God, jeez. This is all just relative. This is all just talking about relative to each other. CMB quadrupoles, that's actually the axis of evil can be explained in the sense that a full statistical description was not done until very, very recently. And once you do an actual full description, a statistical analysis on all variables, not just some, you actually find that discrepancy, or that axis of evil, ain't a thing. All right. Doesn't earthquakes and tsunami retard Earth's rotation? Not a geophysicist, but I'll look at this. Invariably, when major earthquakes or tsunamis occur, we are inundated with news articles declaring that the Earth, as a result of the force coming from these catastrophes, has slowed its rotation rate and/or axis as it moves. The rotation rate is said to decrease by microseconds and the axial tilt by inches. Okay. This isn't the first time a massive earthquake. Blah. Okay. All of this sounds very technical and convincing, but we shall go through it line by line to determine its validity. First, if we add up all the earthquakes occurring on an annual basis, there are an average of 1,450,000 per year. Big number. About 90% are between 2 to 3 on the Richter scale, 9% are from 3 to 4, and the rest are from 4 to 9. Let's say, for the sake of argument, that about 25,000... Hey, Dr. Clive, I could have used you earlier when I was talking about the actual math stuff, but I'm glad you're here now. Let's say, for the sake of argument, that 25,000 significant earthquakes occur per year that affect the Earth's rotation and figure axis the way Dr. Gross claims. Let's say we take the estimates from 10,000 years to 8,000 BC. This means 250 million noticeable earthquakes occurred since 8,000 BC. Let's also assume, based on present data, that the Earth's rotation changes by 0.5 microseconds for significant earthquakes. No. Let's not. Again, not a geophysicist. Looking at you, Tony. But I am going to assume, maybe falsely, that not all earthquakes are equal in the sense of how they apply a torque to the Earth. Therefore, I would imagine that, I don't know, maybe I'm full of shit on this one, but could an earthquake potentially speed up the Earth? And so this is assuming that all earthquakes slow the Earth. Actually, let's Google this. Can an earthquake, doing my own research, increase the Earth's spin? Oops. Sorry, Luna is still on my keyboard, so. The authors of this study find that earthquakes do indeed serve to make the Earth more compact, thus decreasing its moment of inertia, because they leave total angular momentum unchanged, increasing the rotation rate and decreasing the length of day. I think the answer to that question is yes as well. Earthquakes and the Earth's rotation. New calculation of the effects. This is from 88. Wow, all right, this isn't really modern. A new calculation of the effects of past earthquakes on the speed of the Earth's rotation does not account for the observations, but raises important questions in astrophysics or geophysics. That the speed of the Earth's rotation is not constant is, of course, familiar, although the world's observatories still count on a little publicity from their annual announcements that the year just past happened to be a few milliseconds longer or shorter than expected. Moreover, there is no shortage of explanations, for season and secular changes. Tidal dissipation, glacial changes. Hey, look, it's Dr. Gross. So, apparently, Sun Genesis was looking at also data from, the 80s. Complicated problem. Calculated effect of earthquakes on the inertial constants of the Earth is striking, affecting the moment of inertia about the rotation axis, but not the two components at right angles. So, this is suggesting that this is from 1988, that the speed of the Earth's rotation that past earthquakes really have nothing to do with the speed of rotation. Or, not nothing to do with, but they don't match. That the earthquake history does not seem to match up with the change in rotational speed. Yeah, so this is, as I was guessing, is he is only addressing that earthquakes only slow the Earth's rotation. And I don't believe that is the case. Including only earthquakes. There are hundreds of aftershocks, blah, blah, blah. Second, although the Poor-Warren method by the scientists could measure changes in the Earth's rotation, the method is flawed and presumes the Earth is rotating before it interprets the data. The method commonly used is the VLBI. In brief, two interferometers can detect phase are placed on either side of the Earth, 8,000 miles apart. Light from a distant stellar object is absorbed. Yeah. If there were any difference in the phases of the waves between the interferometer, this means that something has moved. No, it doesn't. Oh. If there is a change in the phase between the two waves, that means that there is a asymmetry in the brightness distribution of that object. It has nothing to do with motion of the Earth. Now, what does have to do with the motion of the Earth is what's known as aperture synthesis. The idea that you can synthesize a telescope the size of the Earth based on its motion. But, as he has clearly shown, you could make an argument that, in fact, it is not the Earth that is rotating, it is the sky that is rotating. That would still give you aperture synthesis. But this statement is wrong. If there is a difference in the phases of the waves between the two interferometers, that means something has moved. No, again, it means that the source is asymmetric. Either the source has moved, the Earth has moved, or the radiation itself has moved. It is find it perfectly justifiable to say, yep. Hence, there is a difference between how the single source, stellar source, is received by the two interferometers. It is then assumed the difference is because of the Earth's rotation. No. Again, I've already stated why. This flaw is especially significant since it is already known that stars, quasars, and galaxies have proper motion. That is, each of them has slight independent motion with respect to other stars. In fact, the proper motion of some objects is even greater than their parallax motion. That is true. Barnard star is a prime example of this. They also have independent long-term drift motions. Both of these would easily show up as a phase shift in a VLBI measurement. No, that is an incorrect statement. Again, phase shift is asymmetry. Also, the motion of the Earth affects what is known as the UV plane. That is the phase space that you are sampling, or that is the space you are sampling the brightness source distribution. Basically, the image of that object. So, the motion of the objects, the motion of the proper motion, the parallax over a single day is inconsequential. Effectively, what that would do, what it would really do is that it would blur, or it would change the what's the word I'm looking for? It would shift the sampling of the object. However, that motion, proper motion, as he described, proper motion, what's the word I'm looking for? Parallactic motion, long-term drift, these are so small in comparison to the motion due to the rotation of the Earth. No, I can tell you, I did my thesis work on interferometry. No, this is not observable. No. No. Consequently, it is absolutely necessary to distinguish between the phase shift as caused by the sun. Okay, I can't read this anymore. It's just fucking wrong. Doesn't NASA use the heliocentric system for its probes and satellites? Person asked, blah, blah, blah. Interesting. Here we go. The NASA representative answered in the negative, stating, if the universe were geocentric, all of our calculations for space probe trajectories would be wrong. The person also asked the question, then sent NASA's answer to this author as a proof of the heliocentric system. Accepting NASA's invitation, I then sent a formal request to the NASA website asking them to show proof why a geocentric system would not work. After 6 weeks of not receiving an answer, I contacted the representatives by private email and asked if they were planning to answer the question. They wrote back to me and stated they did not plan to answer it. After I tried to convince them that, since in this public forum they had, by their initial assertions against geocentric navigation, already committed themselves and thus had an obligation to the public to defend their position, they still refused to answer. As a rejoinder, I told them that I would be including the entire conversation between them and myself in this present book. The NASA representatives then demanded that their names be withheld, stating, we do not give you permission to quote us or use our names. Okay. How does that show geocentrism or heliocentrism? Because again, let's go up here. Let me make sure I've got the full context. In other words, NASA tries to give the impression that only the heliocentric model will work. Through email correspondence in October 2005, NASA representative personally invited this author to a Q&A. A few weeks prior, the same representative answered the question in the form regarding whether NASA's probes sent in space tracking using the geocentric system rather than the heliocentric system. So here you have a problem. If you were to ask me 2 years ago, what is a geocentric system? Describe the geocentric system. I would say the Earth is at the center of the solar system, and that everything revolves around it. That is how how scientists think of geocentric model, or I'm assuming NASA representatives think of the geocentric model. Their conception of the geocentric model is neo-tychonic. So really the question should have been, can probes be used if you assume a neo-tychonic model? I would be interested in hearing their answer. But because, again, we've established that effectively, from a relational standpoint, they're basically the same. Deception. That is a deceptive tactic, seeming to imply that the NASA representatives know the right answer but don't want to say it because reasons. GPS, does the phase of Venus disprove Ptolemy's geocentrism? Ptolemy's? Yes. Although certain versions of Ptolemy's system seem to demonstrate its inability to account for Venus's phase, the truth is that these versions no more deny the basic model of Ptolemaic geocentrism than the errors in Copernicus's original model, would discount heliocentrism via Kepler's corrections by means of ellipses. Upon close inspection of Copernicus's diagram, we can understand why so many people have unduly convinced that Ptolemy's model is lacking. Okay, this is what I can say. If you're using a Ptolemaic model, not a neo-tychonic one, a Ptolemaic model, the Ptolemaic model does not work. You cannot make, it doesn't matter about circles, it doesn't, as opposed to ellipses, it doesn't matter about distances. What we're talking about is the geometric phase is based on your point of view from a geometric standpoint. How much of the illuminated surface you can see at any given time. The Ptolemaic system does not predict, I don't care what Ptolemaic system you use, but what we see in actuality is that as Venus gets fuller in phase, it gets smaller. Its angular size decreases. As the angular size increases, you see more of a crescent phase. Now, think of it as the Earth or the Sun is here, Venus is going around, we are out here. So it would make sense because in a heliocentric system, because, again, me, I'm the Earth. Actually, no, you are the Earth. Here is Venus. It's close to you. But the Sun is here. Most of the light is hitting the backside of Venus, the part of Venus you cannot see. It's a simple, you can draw this out, but I assure you, you will see that in this configuration, you will see Venus as a crescent based on our geometric position. And notice that Venus is close to you. Therefore, Venus is larger in angular size. Move Venus over here. Now you are seeing more of the illuminated phase of Venus, but because it is further away, the angular size is smaller. The Ptolemaic system, where the Earth is centered, the Sun goes around the Earth, and the Venus goes around the Earth on an epicycle, you cannot replicate that relationship in phase, in both the phase and angular size. It's just not possible. So this assertion that, it's that heliocentrism should be thrown out because Copernicus's model wasn't accurate in predicting things is a red herring. I hate using logical fallacies. It's not the same. It's not comparing apples to oranges. The Copernican system, because it used circular orbits and because it still used epicycles, because of the whole uniform circular motion business, it failed to predict long-term positions of planets because the small errors compounded over time. So did the Copernican system. As I said earlier in this stream, the two models were not any better at predicting the positions of planets in the future, one to the other. But with the Copernican system, it did get the relationship between the phase of Venus and its angular size. The Ptolemaic model does not. Therefore, it doesn't work. Again, in a neo-tychonic model, I think you can get the geometry right such that you could see Venus's phases right. But in a Ptolemaic system, no sir, no ma'am, no nothing. No. Just no. The geocentric model may include ether, but didn't Einstein's theory eliminate ether? Interesting. May include ether. I'm not going to go over this. Interestingly enough, as that some infinitesimal blah blah blah. Yes, Einstein didn't like quantum mechanics. Is space just space? Not going to go over this. This is outside of this argument. Essentially, I think they're going to claim that ether is a thing. Planck ether, not what I'm interested in right now. Isn't it impossible for the stars to travel so fast around the Earth? Who said? Who object? What? I have never thought of that as an objection for the geocentric model. Sup on the level. Howdy. So, where is this objection coming from? Isn't it impossible for stars to travel so fast around the Earth? No. Skipping that. The effect of the Michelson-Morley experiment, blah, blah, blah. Lorentz transformation would actually cause the thing to physically shrink. Which it doesn't. Doesn't redshift contradict a smaller... here we go. Doesn't redshift contradict a smaller and younger universe? Even assuming the redshift is an indicator of age, velocity, or distance, it is interesting to see what happens when you use Big Bang's cosmology very own formula for measuring the age and distance of celestial objects. The age is calculated by the formula T equals T naught times 1 plus Z raised to the negative 2/3 power, where T naught is the current age of the universe and Z is the redshift. Most modern cosmology believes the universe began during a Big Bang. Using their own assumptions and scale factors, it is believed that this seminal event occurred 13.7 billion years ago. Let's say NASA finds a distant object with a redshift of 1. NASA will then plug in the value T naught equals blah, and then compute a value for T, which is understood as the age of the universe, when the radiation emission of blah, blah, blah. In this case, Z equals 1, T equals blah. Since then, since using the number 13.7 billion years is completely arbitrary, for it is based on the unproven Big Bang assumptions of the universe, wrong. It is not based on unproven assumptions. And I also have problems with this. Dr. Clive would be a better person to say this, but I am curious about this, because this would be model dependent, as in, I would imagine that this is based on the critical density of mass energy. So since we're not even talking about the critical density of mass energy, I have an issue with that. But let's say that it's completely arbitrary. It is not completely arbitrary. It is based on the Hubble flow, and it is based on CMB observations. Yes. Is there a Hubble crisis? Yes. Do the two methods indicate a Hubble constant that is irreconcilable from a statistical point of view? Yes. Hubble says it is 72. CMB says it is 68. Within the error bars given for each measurement, they are not reconcilable. However, looks like Einstein de Sitter universe scale factor proportional to T to the 2/3. Okay. Let's move on. Let's say we assume T naught is 6,000 years instead of 13.7. In this case, Z equals 1 is 2,121 years. In other words, when an astronomer sees a star with a Z factor of 1, he might as well assume the universe was 2,121 years old rather than 14 billion years old, since the Z factor is only a function of one's assumption regarding the beginning of the universe. If an astronomer finds an early, even more distant object, the age of the universe is blah, blah, blah. Okay, sure. Let's just, again, you are stating that that 13.7 is arbitrary. It is not. But then you were saying that 6,000, then what, 6,000 is not arbitrary? Also, this 13.7 billion years is consistent with other indicators of age that we have, such as the age of globular clusters, based on turning point observations, based on when things move off the main sequence. 2,000 years, not so much. That also contradicts, that also goes against the age of the Earth. So, no. Of course, the biblicist does not interpret either the 2,000 or 1,000 years as different times that the stars were created, for he holds on a dogmatic basis that all stars were created on the same day. It only means that as the firmament expanded, carried the various places stars within it, their wavelength would be stretched by their medium, the firmament, in proportion to the distance that they were created from the Earth. Interesting. So, the firmament is expanding? So, okay. So the explanation for redshift is that the firmament is expanding. Which then begs the question, and this is a valid one as opposed to the idea of expanding into something else. Well, maybe not. So the firmament is expanding. The Earth is not expanding, but the firmament is expanding. My naive question is expanding into what? But you wouldn't. That's a nonsensical equation or question in terms of modern cosmology, because the universe is itself. Yeah, okay. This is the first time I've seen this. This is interesting. I've never heard of the idea that the firmament itself is expanding. The other problem with this is that this whole idea that stars are all created the same day. No, stars are definitively of different ages. We have shown this through modeling. Thus, if we were to understand redshift as a distance indicator, we would see as distances in redshift values today as merely the result of the differences of the original placements of the stars on the fourth day of creation. The stars that were placed closer to Earth will now exhibit lower redshift values, and vice versa for the stars further away. That is only if the universe is expanding. Or the firmament. Interestingly enough, if we use modern science's formula for measuring the age of the universe, when the cosmic microwave background was released, we get very close to the time that has been predicted. The firmament would create a 2.73 Kelvin temperature. The formula is T equals T naught. Oh, come on. Not using the right, or not using consistent notation bugs me. Plugging in a Z factor of 1089 for the CMB, the Big Bang Theory arrives at a universal age of 380,000 years after the explosion. That would be the recombination age. Whereas the same Z factor, the biblicists obtain 0.16672 years, which puts the CMB well within the first 2 months of the first year of creation and after the fall of man. What? And after the fall of man, then, when, as we will see in Volume 2, Chapter 12, according to Hildegard, the universe began rotating and the firmament needed to remain at 2.73 Kelvin to be stable. What the shit? $1.6672 years. Well, according to the biblicists, that's still not a day. That's still not a couple days. And so the universe began rotating at this when the sea. So the universe was stationary until 0.16672 years after the point in creation, at which point the universe began rotating, and the firmament is now 2.73 Kelvin and is stable. Other factors pointing to a smaller universe: transverse velocity versus radial velocity, blah blah blah. Puzzling aspects of the parallax. This proves nothing, and actually, again, it violates other pieces of evidence which do agree with each other that the universe is billions of years old, at least 4.5 billion years old. So, what? Okay. This also doesn't factor in that they were making the assumption smaller, younger universe. You've addressed the younger issue, but not the smaller. We have distance measurements that are not based on anything on Big Bang. We have distance measurements that show that, for example, the Andromeda Galaxy is 2.7 million light years away. Not a small universe. So, one of the more puzzling aspects of parallax is that some stars have a very small or even negative parallax, yet have large proper motions of stars. It is reasoned that stars with large proper motion are closer to the Earth than stars with no proper motion. Yet, in a sample of stars with a large proper motion, 22.5% were measured by parallax to be at least 300 light years away from Earth. If the parallax distance is correct, then these particular stars are moving at tremendous speeds relative to the star field. Citation is 388. Based on parallax and proper motions measured by 276 faint stars, as cited in The Deceptive Universe by Jared Thacker. So he's quoting I need to go eat soon. He's quoting a value from a book and not the actual source. So that is not how citations work. When you cite something, you need to cite the original source, not some dude talk. This is what lawyers would say. He is hearsay. Not saying that this is not true. All I'm saying is that this citation is meaningless to me. And there are things such as high velocity stars. So I would need to know relative velocity relative to the sun. What is this? There are things called high velocity stars, so I would need to know what the velocity of these stars what velocity these stars are moving at in order to determine whether or not there is actually a problem here. And I would also be curious. He's made 12 additions to this. He's talking about something that was quoted in 1983. Are you telling me that in your 12 editions, Looney, in your 12 editions, there's Luna, in your 12 editions, you could not, in fact, look up the Gaia measurements of these stars? Yeah, she's so cute. Oh, look at her. She's so cute. Yes, I know. Sorry. All right, guys. I'll get back to it. Sorry. Oh, I just woke her up. So, yeah. This is outdated. This is old data. And he didn't bother to actually look into it since then. Given the radial... All right, so what is this? A proponent of the Big Bang would be predisposed to interpret the above graph as an indication that the radial velocities of stars as measured by the Doppler shift from the expanding universe increases the greater the distance of the star from the sun. No. That is not how scientists would interpret that, because within the context of the galaxy, proper motions are far larger than the Hubble flow on these scales. That is the case in the local group when we're talking about millions of light years in size. The Hubble flow is not large incomparable to the proper motions of the various objects. So the assertion again here that a proponent of the Big Bang would be predisposed to interpret the above graph as an indication that the radial velocity of stars, as measured by Doppler shift from the expanding universe, increases the distance the star is from the sun. No, that is not what we would be predisposed to interpret. For all the stars in the study, there were a pronounced correlation between the measured parallax distance of the star and its proper motion relative to the sun. Again, I would need to see what this is. Distances in stars, velocity relative to the sun. Which velocity? Radial or translational? Because again, or traverse as he calls it, this is proper motion. He's talking about stars with large proper motion. When you talk about the Hubble flow, you're talking about radial motion, motion away. Proper motion is motion side to side. Granted that there is the correlation here is very curious. I would have expected it to actually be the other way. Would actually be anti-correlated, that the closer the object is, the faster it would be moving. But again, I don't know where the paper is. He's not quoting the paper. He's quoting some book, which I am going to assume has an agenda. So, yada. Yeah. Again, straw man, whatever, deceptive. It is not a apples to apples comparison. It is a deceptive or deceitful comparison. Graphing the radial velocity against the transverse velocity produces the following contrast. Velocity When an object is slow, it has a large, most of its velocity is what velocity? The velocity is a function of radial versus proper motion. Radial gives you the z-axis. The translational motion, or the proper motion, gives you x and y. So how are you getting the velocity? How are you able to do this? How are you able to compare these that are apples to apples? This is a function of these two. Are they saying that when you combine these two, if you have a velocity that is low, then if you were to look at the components, maybe that's what he's looking at. When you look at the components of radial versus translational, slow velocity, they're mostly moving away from us than they are translationally moving away. And then as the thing gets lower and lower, what we're seeing is that the radial velocity is no longer a component of the overall velocity. We are seeing that it's basically an uneven function of proper motion. You know what this tells me? This tells me that, just on the face of it, illustrate that there is no, well, I can't say that. I was going to say there is no correlation between distance and velocity. So, in the expanding universe of the Big Bang, it would be an acute contradiction that the farther away a star is from the Earth, the more transverse velocity it would have. No. Again, complete misunderstanding of the Big Bang. The Hubble flow on the scale of the galaxy is almost negligible. So, no. Similar problems are discovered with the absolute magnitude of a star as contrasted with its Doppler distance. Distance from a star, 390. Absolute magnitude is the apparent brightness of a star, okay, as seen from through, okay. Distance from the star from the Earth from Doppler shift. Oh, that's wrong. You cannot, the Hubble law is improper use. You cannot use the Hubble law. It is improper to use the Hubble law to determine the distance to the star as a function of redshift. But this is a correlation, so why? It says that the brightest stars would be, and see traverse velocity and radial velocity. He quotes YouTube. What do you have so far? Absolute magnitude, UV, BV color index. For those of you who are not in the know, BV color index is the magnitude of a star's brightness in blue versus the brightness of a star in green. If the B minus V index is negative, that means the star is blue, or relatively speaking. If it's positive, it's red. So what this would indicate is that what they're trying to say is that as a function of absolute brightness, or absolute, or luminosity, the intrinsic luminosity of an object, then you have a color index correlation. And yeah, spectral parallax. So here you have that, let's see, the BV index indicates the distance and the difference in the intensity from the blue part. Yep, actually green, but who cares? If the BV index is plotted against the absolute magnitude of stars accepted as being the 20 or so nearest stars to the Earth, it results in the following diagram. Okay. The fainter the star is, the redder. Sure. Yep. Got it. Okay. Makes sense. Below left is the current H-prong diagram, color index. The below right is the same, 90 degrees, to show how it plots identical to the above plot. Okay, rock on. Kill the white man. Using the above plot graph, yep, all right, cool. That's all. Distance modulus. Go nuts for those cronuts. You forgot the extinction due to dust, but you know, let's not quibble. Why can't I? Okay, yeah. Above calculation is the distance to Proxima Centauri coincides with both BV and absolute scale. Blah blah blah. If, however, we use the BV index from the above plotted graphs to determine the absolute magnitude of Betelgeuse, 1.5 correlates to an absolute magnitude of about 14, not negative 1. Oh. Oh my God. All right. Here's a fun fact. The luminosity and therefore the absolute magnitude of a star, and probably 5 people are watching at this point. I shouldn't care. Anyway, thank you all for being here. Thank you all for watching. I love the fact that you've stuck with me for, I think, 3 hours at this point. Anyway, the luminosity or absolute brightness of something, absolute magnitude of something, is related to two things. One, temperature, which is a direct function of B minus V, but it's also related to radius. So, the stuff up here, right there, those would be dwarfs. Those would be stars that are effectively in the same stage of evolution as the Earth. These are stars that are burning hydrogen and helium in their cores. Funny enough, he said it should be, what did he say? It should be around, it's measured to be -5. Looky. Over here, there are stars with that same color index that are in the range of -5. Why? Because Betelgeuse is friggin' huge. It is a supergiant. It is between now, and I do mean right now, and 100,000 years from now, it could go boom as a supernova. Again, either does not understand basic astronomy or is lying to you. This is because what they are doing is that all of these different stars have different radii. They are in different stages of evolution. And as you can see from the plot that they provided, depending on the stage of evolution, that is going to radically change the absolute magnitude as a function of color index. This is degenerate. If you have the color index of a star, you cannot know absolutely what its absolute velocity or what its absolute magnitude is. It depends on whether or not it is a main sequence star or if it's a giant. Has the book talked about the celestial gap yet? I have no idea. I've been skipping quite a lot of it. Objection 20. Don't the global positioning satellites prove relativity and deny geocentrism? Relativity. Prove relativity, or they support relativity? Yes. Does it have anything to say about geocentrism? Well, probably. I don't know. I don't know about that part. Sagnac effect. is embedded in millions of receivers. Another relativity writer points at blah, blah, blah. Propping up special relativity and dismissing the GPS's difficulty with the Sagnac effect is accomplished by claiming, in the rotating frame of reference, light will not appear to go in all directions in straight lines with c. The frame is not an inertial frame, so the principle of constancy of the speed of light does not strictly apply. Instead, electromagnetic signals traversing a closed path will take a different amount of time to complete the circuit. What's wrong with saying Betelgeuse is just a star, so saying Betelgeuse should have no effects? Betelgeuse. Oh, sorry. What's wrong with saying Betelgeuse is just a star, so saying Betelgeuse should have no ill effects? Betelgeuse. Damn it. Damn it. Never. Really wish it would say. Really wish that would work one of these days. Much of this selective approach in dealing with the mechanics of GPS will probably go unnoticed by the general public. Why is that a selective approach? Why is this wrong? How is that wrong, other than you just saying it's selective? La, 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 la. In other words, special relativity is not exempt from maintaining its principal postulate that the speed of light is constant when rotation is involved, since the Sagnac effect does not depend on rotation. In other words, JPL technicians pre-program the GPS computers with the Sagnac effect in order to compensate for a speed of light that varies between advancing and receding satellites. Okay, if the Sagnac effect is real, then why wouldn't they program that in there? I think what you're trying to imply is that it's reverse engineered. As a person not entirely familiar with the Sagnac effect, I will forego this analysis, or forego talking about this on any intelligent level. Oh, god damn it, Mike. Fucking this dude. Today we hear a lot of talk of dark matter in cosmological circles. I don't know. I don't. I don't want to take him anywhere. What does he say? Fuck. Believe it or not, the Hubble Space Telescope over the last several years has been giving us maps of something called dark matter. Dark matter makes up most of the universe. No, it doesn't. It's not made of atoms. Your chemistry teacher was wrong in saying that the universe is mainly made up of atoms. That's not proven. Whole generations of textbooks have now had to be thrown out. It's invisible. No, you cannot photograph dark matter. We know it's there because of its gravitational presence. No, none of this is conclusively shown. Dark matter, cold dark matter, could in fact be neutrinos. Neutrinos have been seen, just not moving at those speeds. So, no. It's possible, yes, there is an alternative that the cold dark matter is in fact some exotic particle, some weakly interactive massive particle that we've never seen. Yes. Is that possible? Yes. But to say that whole generations of textbooks have to now be thrown out, that is not a correct statement. You cannot say that. Your chemistry teacher was wrong in saying that the universe is mainly made out of atoms. Again, not a proper statement to make. It's possible, yes, but whatever. How did he come by this in 1970s? Vera Rubin. Awesome. She got me into astronomy. Vera Rubin, Caltech, proved that galaxies do not rotate according to Newton's laws. Actually, Zwicky found that out in the 50s, but since he was kind of a dick, no one really paid attention to him. Yeah. Basically, just to skip over it, what we find is that with spiral galaxies, the rotation of stars as a function of distance is essentially level, is essentially constant. There are wiggles, but essentially it's constant. We would expect that given a central mass concentration with the amount of mass decreasing sharply as you move outward, that it would be more Keplerian, that the velocity would drop as a function of distance. In order to explain the things that will the constant velocity that we see, you have to, or not have to, the best explanation to account for those observations is overlaying a spherical distribution of relatively constant density matter that we cannot see, that is, dark. But there are those who also believe that, and there are a significant number of them, they believe that dark matter are in fact massive compact halo objects. Now, I think that idea is becoming less and less favorable as more and more evidence is suggested, but again, yeah. Dark matter has become an essential ingredient in cosmology standard model. Cosmologists fix this problem by adding, that's because the Big Bang on its own fails, describing how galaxies congeal. Yeah. Shortly after the birth, assuming that the universe is only composed of baryonic matter. That is correct. Problem is that gas and dust made from normal matter spread too evenly. Yep. This is kind of suggesting that we have added the dark matter to make this work, and then it was then observationally verified by Rubin. That's not how that worked. We found evidence of dark matter a lot of different places, and then cosmologists used it to fix the problem that the universe would not evolve fast enough, would not come together fast enough. Dark matter may not be the cure-all it seems, of course. If you believe in dark matter, you discover there is too much of it. Maybe. He and his colleagues have found evidence that stars and globular clusters are moving faster than the gravity of visible matter can explain, just as they do in large galaxies. Okay. He believes the answer may be a breakdown of Newton's law of gravity. Yes, that is also possible. The virial theorem in galactic clusters. That is correct. Essentially, the star or the galaxies in those clusters were moving more rapidly than the virial theorem would predict, based on their age. So, and Betsy Ross would sit around and say so and so and so. All right, believes the answer may be a breakdown. Okay, reverse square law. Yeah. Yes, there are the modified Newtonian dynamics has been explained, but apparently, and I haven't watched your most recent video, apparently there is evidence now, observational evidence now that says even if you invoke Mond, you still need dark energy, you still need dark matter. So Mond may not be correct either. Here we go. Above shows that dark matter is a halo around the galaxy. In reality, modern cosmology believes that dark matter pervades the whole universe. Those aren't mutually exclusive. Dark matter is a halo around the galaxy, and it's also a halo around other galaxies. It does not mean the picture that we showed does not exclude the existence of other discrete pockets of dark matter in the universe. So again, this does not follow. The recent discovery of dark matter and dark energy underscores the fact that the higher chemical elements that make up our bodies comprise only 0.03% of the total mass energy content of the universe. I think that value has changed somewhat, but okay, sure. It's interesting that the author, Dr. Sun Genesis, has only been talking about dark matter, and now throws a quote that talks about dark energy. These are two different concepts. How are you equating the two? Do not equate the two. They are not the same. Instead of modifying either the concept of galaxies and what makes them spin, or even Newton's laws, and questioning the basis of Big Bang, modern cosmology instead invented matter it needed without the slightest observational evidence for its existence. No. So yes, that is what he's implying. No, the evidence for dark matter came first. And then it was applied to cosmology. And to say that slightest observational evidence for its existence, no. You just showed Vera Rubin, spiral galaxies, dispersion within elliptical, stellar dispersion, the dispersion of stellar velocities within elliptical galaxies, the motion of galaxies within clusters, the temperature of hot gas between colliding clusters. All of this shows evidence of Big Bang. Shows evidence of dark matter. Kaku knows that dark matter exists by its gravitational presence. He is merely referring to the fact that the gravity of galaxies doesn't work unless science arbitrarily adds dark matter in. All right. Yes, we are working under the assumption that relativity, that our understanding of how gravity works on certain spatial scales is correct. On these scales, classical mechanics is just as viable a description as general relativity. Yes, it could be wrong, and people are looking into that, like Mond, can't think of any other alternatives to gravity, but I know that they are out there. My postdoc advisor was very much in favor of a modified, very much in favor of Mond, or the possibility that Mond was correct, or is correct. So the characterization that cosmologists have just doubled down, thrown all of their money into the idea that dark matter is a thing, is not accurate. Nor is it accurate to say that cosmologists believe that dark matter is invisible, is some exotic particle we've never seen before. That is also not accurate. Kaku claims that it's a wholly different substance. Kaku could potentially be wrong. Stop quoting individual scientists and quote the science itself. Yet Newton's law acts as if dark matter was normal baryonic matter. No, it does not. It acts as if it's matter, as if it is gravitational matter. Doesn't necessarily mean that it's baryonic. It could be, but it doesn't mean it. Need it to be. Dark matter can change its spots depending on its environment. How? Are you talking about the globular cluster thing? Maybe. I have to look into that. I think I have heard of that problem. The problem would be that dark matter does not collapse on those types of spatial scales. So the idea that dark matter would be affecting the velocities of stars within globular clusters is unexpected. I'd have to look into that more. But outside of that, I don't see any sort of changing spots. In all this conjecture, not the slightest shame in admitting calling this science. Yeah, I don't have shame in calling it science. Conjectures of modern cosmology make dark matter appear to be is no different than a magician pulling out a. That's derisive or that's what's the word I'm looking for? I can't remember the Latin term for it. Ad nauseum, ad infinitum. You're ridiculing it because you aren't making any sense. The classic nope. No. A possible solution to the dilemma is to employ Kepler's law of gravitation, and rather than Newton's. Kepler's law focuses upon the mean density inside the orbit, thus allows the orbit to increase in speed the farther it is from the center of mass, whereas Newton's law holds that the mass of a body is concentrated in the center of an orbit, which then makes the gravity decrease. I didn't realize that Kepler had come up with his own law of gravity. I will have to look into that, but the idea that gravity is dependent on density as opposed to mass doesn't work on local scales. Again, if you're going to make the claim that something changes its spots based on situation, claiming that orbits can be explained as a function of density and everything else that we've seen on the Earth is a function of mass, that seems like it's changing its spots. One interesting irony of the dark matter issue, however, whereas the discovery showed easily modern cosmology will abandon the empirical approach in order to save. No, the discovery of Rubin's provided science with the solution to the dark matter problem, but it was summarily ignored. Rubin discovered that if we add all of the known motions of the galactic plane, the sum of the motion is zero in the Earth's vicinity. This finding amounts to the Earth being in the center and was the very reason Rubin said before her research, hopefully it will not force a return to the pre-Copernican view of the hierarchy of Mach. I would have to look into that. I did not know that this was a thing. Doesn't dark energy prove the Earth is expanding outward along with everything else? Dark energy? Wouldn't that mean actually just the Hubble expansion? It's the fact of the universe expanding. If you take dark energy out of the equation, then in a sense you could think of the Earth as expanding on a ridiculously small scale. Dark energy is simply another fudge factor of modern Big Bang cosmology. In this sense, I will kind of agree, mainly because of primarily my ignorance. I am uncomfortable with the fact that dark energy does not have, as far as I'm aware, Dr. Clive could correct me, but as far as I know, dark energy doesn't have a really good physical underpinning. It is explained by its necessary effect as to its proximate cause. That's my understanding. So in this sense, I would agree that dark energy is something of a fudge factor. Hubble expansion does not affect gravitationally bound systems at all, or to a very minor level, to being that it's insignificant. Because I would have thought that Hubble expansion would in fact affect all systems, gravitationally bound or not. But see, this is what I'm talking about way like 3.5 hours ago, is that there is stuff in cosmology that I want to pay more attention to rather than dealing with this nonsense. And yes, I called it nonsense. I'm frustrated. At all. Interesting. See? That is interesting. I will have to look into that. I thought it was just simply such a small effect that you wouldn't notice it. Yeah, looking into that. Because the acceleration needed for the Big Bang expansion could not occur without it. Well, as observed, yes, but not as a first principle, because we believe that there was a Big Bang theory prior to the existence of dark energy, which showed that the universe was expanding. It would be the same as if you put a gallon of gas in your car to take you on a trip that you know requires 20 gallons. Instead of going on the trip, you sit at your desk and work out a mathematical formula that contains The greatest surprise, again, Kaku, the greatest surprise of the WMAP data is that 73% of the universe is totally unknown form called dark energy, introduced himself by 1917. The expansion is effectively a small perturbation. Yes, that's how I was thinking of it. It was that the Hubble, again, the Hubble flow would be small in comparison to the motions as dictated by gravity. But suffices to say, WMAP showed no such thing. WMAP merely showed that the universe showed a universe that had too little energy to do what modern cosmology desperately needed to do, so they invented the needed energy and called it dark, because it has to exist and we don't see it. WMAP? I was not aware that WMAP was what called, for me, the dark energy it might have settled on how much of the universe is composed of dark energy. But dark energy was a direct consequence of supernova, type 1a supernova observation. Brian Green says, what force could be driving every galaxy to rush away from every other one? Blah, blah, blah. Einstein's equations show that if space contains something else, not clumps of matter, but an invisible energy, sort of like invisible, that's... Am I getting to the point where I can't read anymore? Not clumps of matter, but an invisible energy, sort of like invisible, that's uniformly spread through space. Then the gravity exerted by the energy mist would be repulsive. Okay, yeah. 0 point energy. Got it. Yes. Supernova observations. Yes. The draw to Einstein is very great. Blah, blah, blah. The draw to Einstein is very great in modern cosmology. Since he is propped up as such an authority, the temptation to trace current theories to his theoretical foundations is quite common. We do not hold up Einstein as some sort of prophet. We hold up Einstein because he actually incorporated a repulsive element to his field equations. If Lorentz had done that, we would go to Lorentz. It's only because he actually has a solution, or he has something that could potentially explain a repulsive pressure to the universe. It's not like we're like, oh wait, let's see what Einstein had to say about it. No, it's basically the only place that we have to go on if we are going to keep general relativity intact, or if general relativity is the best explanation. But as I've already stated, in case anyone wants to clip this, is that there are alternatives to GR that are currently being explored but have not been robustly shown to surpass it. The real truth is that Einstein's classical general relativity can only account for 4% of the universe. No, that is not true. Since the universe is now claimed to be 96% dark energy and dark matter, and if they still want Einstein to be their mentor, they need to make Einstein's theory come up to snuff. Again, it's not about Einstein. It's about general relativity. And let me I've been wanting to say this, and of course it's happening at 3 hours, 33 minutes into a stream, so I probably will have to say it again, is that I absolutely, no, that's too strong of a language. I don't like Einsteinian mechanics. I also don't like saying Newtonian mechanics. It's general relativity and classical mechanics. The reason why I don't like saying Einsteinian relativity or Newtonian mechanics is because that implies that one dude came up with all of it. No. General relativity and classical mechanics were both theories that were postulated first by Einstein and Newton respectively, and then through years of continual study and continual improvements has been developed to the theories that they are now. Obviously, classical mechanics has been, general relativity is a better description than classical mechanics. But the fact is, there are aspects of classical mechanics that Newton didn't know about. And I am sure there are aspects of general relativity that Einstein had not thought possible, or at least implications of general relativity that Einstein had not considered. These are theories, these are practices of science that are constantly being developed by people, by hundreds, if not thousands of people around the world over time. The idea of just claiming this is Einstein or claiming this is Newton is a disservice to people who have put their lives into developing these theories into clearer and more accurate descriptions of the universe. It pisses me off when I see this sort of shit where it looks as if Einstein or Michio Kaku or Neil deGrasse Tyson is put up as some kind of messiah or prophet to science. Hail Sagan. That is not how science works. And when people do that, they illustrate to me that they have no conception of how the science community operates, how science actually is done. They then decide to inject it with a booster shot called Lambda, which is 73% of the 76%, which is known as LCM or Lambda CDM. Lambda is okay. Yeah, you're not going to define what Lambda is, buddy. Not gonna do that little, critical density of mass energy. No, I'm just gonna ignore it. Okay. Right, that's genuine. That's what's the word I'm looking for? That's genuine. Looney, I can't see the pen. I can't look through you. You make very good door. Really horrible window. All right, let me move this over here. There we go. Friedman came up with his solutions, yada yada. NASA puts it, Einstein first proposed the cosmological constant. Yep. Friedman, a Russian, I didn't know he was Russian, mathematician, realized this was an unstable fix. Okay. In retrospect, when Hubble relieved some of the problem by interpreting the redshift of galaxies as a sign the universe is expanding, still, in order to have the matter move yet remain homogeneous, the value of the expansion, h, as well as the value of its density, omega, and the energy to propel the expansion had to fulfill the Goldilocks rule. It had to be just right or there would be no universe. It has to fit empirical data. That's how science works. I agree. When Zood, nothing really wrong with just remembering the key names, though regardless of how ripe or not something was for discovery. Yes, I'd like to give credit to the person who came up with the theory. Yes, but I do not attribute that theory to just be that person. It's general relativity. It's not Einsteinian relativity. Various scientists have spent their entire careers trying to figure out the perfect combination of these three values, but to no avail. Accurate. Postulating because they are trying to get the model to represent empirical data, and when new empirical data comes in, then they have to tweak the model if it doesn't match. That is how science works. Christ. It's a Roman numeral, buddy. It's a Roman numeral 1, not an Arabic 1. Measuring revealed that the universe wasn't slowing down, it was actually speeding up. This meant that there was no possibility. This new acceleration could be H2, molecular hydrogen, could be accounted for by present amounts of energy in baryonic matter. A related problem is that the universe is flat. That requires expansion or inflation. Big Bang advocates want a zero sum because they believe it will answer the haunting question concerning the origins of the Big Bang. It came with the answer being it came from nothing. No. Our understanding of physics cannot make that claim. There are alternate theories of gravity, like loop quantum gravity, that states that there was in fact a universe prior to the point of creation, t=0. So this idea that it came from nothing is not scientific consensus. Lawrence Krauss may believe it, I don't know. But again, individuals can be wrong. Do not quote individuals, quote the fucking science. Oh, yes, Einsteinian relativity versus Galilean relativity, yes, that I would do. You were all stardust. That is true. So forget Jesus, the stars died so you could be here today. This is an atheist's point of view. That is his opinion. It is not the scientific consensus, because science doesn't have anything to fucking say about Jesus or God or anything metaphysical. So fuck that off. Yes, that we look at, lens or the angular size of WMAP results or the quantum fluctuations that tells you the geometry of the universe. I don't know how much more of this I can take. Kaku! Oh, here we go. I've been wondering about this. All right. One last thing before I sign off. One last thing. The proponents of this convenient manipulation of data seem oblivious to their ploys. But George Ellis is not ashamed to admit that the whole thing is based on wishing or presuming that the Copernican principle is true. Actually, a cosmological principle, but who's counting? Additionally, we must take seriously the idea that the acceleration apparently indicated by supernovae data could be due to large-scale inhomogeneity with no dark energy. Observational tests of the latter possibility are as important as pursuing dark energy, the dark energy option in a homogeneous universe. I would agree with that. Theoretical prejudice as to the universe's geometry and our place in it must bow to such observational tests. Precisely because of the fundamental nature of the Copernican principle for standard cosmology, we need to fully check its foundation. And one must emphasize here that the standard CMB anisotropy studies do not prove the Copernican principles. They assume it at the start. The further issue that arises is that while some form of averaging process is in principle, that one should arrive at a large-scale geometry of the universe on the basis of observations. In practice, this is normally done in the inverse. Yep, okay. I will agree with pretty much that the Copernican principle is an assumption. It is a base assumption that basically colors how we approach things. But until you can show me that the Copernican principle is not in fact a good assumption, then, because the opposite is that the Earth is the center of the universe, and I don't see any evidence to suggest that is in fact the case. Because if the Earth is the center of the universe, that indicates that the universe must also be the same age as the Earth. And there is counter evidence to that. Unless somehow the universe is defined separately from the Earth before it came into being, which doesn't make a lot of fucking sense. And yeah, I'm going to start swearing my ass off. I'm not monetized yet, so fuck it. One must blah 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 blah. Machu Picchu is a perfect example of cosmology. Blah. No one at the present time has any understanding of where this energy of nothing comes from. If we take the latest theory of subatomic particles and try to compute the value of this dark energy, we find a value that is just off by 10 to the 100, 120. He is referring to the discovery by Russian physicist Yakov Zeldovich, and later established in quantum electrodynamics or quantum field theory that empty space has an energy of 10 to the 120 more than the dark energy needed to propel the proposed accelerating expansion of the universe. The 10 to the 120 excess energy is the only source available, but it cannot be cut up into slices. It is all or nothing. This is precisely why. Okay. What's a lambda between friends? I, again, can't speak intelligently of this. I am not familiar with, overly familiar with quantum electrodynamics or quantum field theory, so I will have to take your word for that. There's an even bigger problem. Since Einstein's equations require that the curvature of the universe depend on its energy content, and since the energy content is more than that Einstein proposed, the whole universe should be curled up into a space smaller than the dot of this eye. Obviously, it isn't. Interesting that he's been going off and basically saying cosmology, because it can't explain these things, it's false. It's wrong. You can't possibly. But this thing with the 10 to the 120, that's sacrosanct. That's definitely right. Interesting that they would propose that. Richard Liu submitted a scathing critique of the lambda cold dark matter model in a 2007 paper. Again, quote mining. Cosmology is not even astrophysics. All the principal assumptions in this field are unverified or unverifiable in the laboratory, and researchers are quite comfortable with inventing unknowns to explain the unknown. How then could, after 50 years of failed attempts to finding dark matter, the fields of dark matter and now dark energy have become such lofty priorities in astronomy funding to the detriment of all other branches of astronomy? Dude. How long did it take us to find gravitational waves? Century. So we haven't even gotten half to that yet. What is up with this we need to find it now business? Yeah, we haven't found it yet. Give them time. Fuck. And, why do they need time? Because the technology needs to improve in order to actually test some of these things. And in order to improve the technology, what do you need? Money. Hence why there's astronomy funding, fucko, is because we want to see whether or not dark energy and dark matter are in fact right. Hence why Euclid was put up. I need to look more into what Euclid is finding. Anyway, I don't know who Richard Liu is, but anyway, lambda cold dark matter cosmology has been propped by a paralyzing amount of propaganda which suppress counter evidence and subdue competing models. Citation fucking needed. I believe astronomy is no longer heading towards a healthy future charged under the banner of Einstein's extreme eminence and his forbidding theory of general relativity. Have cosmologists been overexercising our privileges? Could this be a sign of a person or camp of people in prestigious institutes who become angry because they are embarrassed? What the fuck? Okay, that's one person's opinion. Oh, come on, dude. He's from Bama. He's from the University of Alabama. Fuck that guy. I love this. Although Liu presents equally flawed models due to the fact that all cosmologists are searching in vain for how the universe started and develops, he candidly admits perhaps all models are equally poor. I'm glad that I'm glad that Dr. Sungenesis recognized that these are equally flawed models because they don't agree with him. Yeah, this again is one person's opinion because, again, theories like loop quantum gravity, quantum theory, or string theory, M theory, these are active fields of research, doesn't mean that we are, in fact, goes against the narrative that we are, in fact, not exploring things. Perhaps, do they have the point, or does this person have the point that we are putting a whole lot of eggs in a single basket as opposed to, yes, but I would argue that's not putting all eggs in a single basket. These are the best explanations we currently have, dark energy and dark matter. And in order to move forward, we need to take that and we need to either confirm it or falsify it, which is why we need money to put into it. And yes, it's political. Anything dealing with money is political. Right now, for the last 2 decades, astronomy has been focused on exoplanets and cosmology, as opposed to, say, stellar evolution or, black hole mergers would. I guess black hole mergers would be into cosmology, or or galactic collisions or something of that nature. There are other members or other fields of study that are being more poorly funded because we really want to answer the questions of, is there life out there, and where did the universe come from, and where is it going to end? 2006, again, you put out 12 editions of this, and you're quoting some from 2006. Organized the Dark Force Task Force in order to bring problems to the fore and seek answers. In the first 80 pages of its report, summarizes dark energy appears to be the dominant component of the physical universe, yet there is no pervasive theoretical explanation for that. I already said that. The acceleration of the universe is, along with dark matter, the observed phenomenon which most directly demonstrates that our fundamental theories of particles and gravity are either incorrect or incomplete. Yep. Most experts believe that nothing short of a revolution in our understanding of fundamental physics will be required to achieve a full understanding of the cosmic acceleration. Yep, I said at the very beginning of the stream that I'm of the opinion that I think with satellites like Euclid, data like Euclid, that we will be able to see a fundamental change or fundamental scientific revolution within our own lifespan. And that is a good thing. So, yeah, I don't see a problem with this. Is not a problem. It is only when you are when you have the assumption that science is absolutist that statement is a problem. Science, modern science, doesn't say that. Modern science is always provisional. So, yes, this is not a problem. The deceptive universe that was cited in the diagrams. Oh, all right. Thank you, Eric. For those reasons, the nature of dark energy ranks among the most compelling of all outstanding problems in physical science. Yes. Which is why many consider it to be necessary, or why many put it as such a high priority for funding, so we can answer that question. These circumstances demand an ambitious observable program. Yep. In other words, modern cosmology doesn't know what the blazes it's doing today. No. It is at a total loss to explain the universe. No, it is not at a total loss to explain the universe. That is your opinion. More so, it was no more so than it was 100 years ago. Do you realize that dark energy was put into effect, I think, in the 90s? So fuck off with your 100 years or so bullshit. Also, the Friedman solutions were not 100 years ago, I don't think. So, yeah. whereas the general relativity was considered the solution to cosmology's major problems in the 1920s. Yeah, GR may not be the most accurate. Rock on. How does modern cosmology deal with these problems analytically? Doesn't WMAP prove the Big Bang? 2010, again, 12 editions, quoting something 13 years ago. The National Aeronautic and Space Administration, a list of top 10 accomplishments. Claim 1, WMAP, map the radiation, yada, yada, yada. In reality, the results of WMAP are so disturbing for NASA and the rest of the scientific community that the European Space Agency decided to launch another satellite, the Planck probe, in 2009 to determine whether the data from WMAP was correct. Kind of. They put it up there because Planck was more precise in its measurements. How is that a bad thing? They wanted to know, I mean, yeah, there were open questions, but essentially they wanted a better understanding of what's going on. I wouldn't say that it was, so disturbing. No, it was intriguing. They wanted better, more precise measurements on how it was determined. And again, you're referencing Planck. Why aren't you quoting Planck? WMAP definitively determined the age of the universe to 13.75, within 1%. WMAP did not determine anything, since it is merely an instrument that collects data. Nitpicking, party of one. WMAP nailed down the curvature of space to within 0.6% of flat. WMAP didn't nail down anything. Not even gonna, no. CMB became the premier barometer of the universe with WMAP's precision that ordinary atoms make up 4.6% of the universe. And Planck made even better. WMAP made... This is all fucking semantics. WMAP's complete census of the universe finds that dark matter took no census of the universe. It merely shows anomalous galaxy rotation curves that... WMAP doesn't even know... WMAP did not look at galactic rotation curves. It looked at the CMB. Two completely different things. Now he's starting to really piss me the fuck off. WMAP's accuracy and precision determine that dark energy makes up 72.8% of the universe. It's certainly accurate and precise, but it made no determinate... Fuck off. WMAP has mapped the polarization of the blah... this is a real breakthrough, okay. Trying to turn lemons into lemonade, whereas the Big Bang Theory predicted complete isotropy and homogeneity for the universe. WMAP found some isotropy and homogeneity, more sounding that the fact that it's actually the quadrupole and octopole. This is a lie. The dipole doesn't show it. Higher multiple values, yeah, one of them, the octopole. It's the quadrupole and the octopole showed that there is an anisotropy in line with the Earth's motion through the universe, but a more robust statistical analysis has shown that that is in fact wrong. Again, 12th edition. Horizon problem, yada, yada, yada. Doesn't the speed of light contradict Genesis 1? Don't care. All right, yeah, I'm done. I am done. I can't take any more of that. I need to sleep. I need more coffee. We are only page 274 of how many? Holy novel Batman. I didn't realize it was 736 pages long. What is space in the geocentric universe? Wow. Oh, hold on. The 666 page. Virtual particles. Christ. Silicon-based life needs containers. 666 to go. A volume. This is volume. Oh yeah, that's where chapter 10 is. I was like, chapter 6 doesn't the Bennett wrote chapter 10. I was like, this only has six chapters. Oh my God. Oh my. Oh fuck me. Yeah. All right. Oh. Okay. Oh, you're welcome, Cygnus. I got heated at the end of that, I will fully admit. I'm still a little heated. Because again, and this is where my patience is waning rapidly, is quote mining. Quote mining is not science. People can be wrong. Neil deGrasse Tyson was wrong about Baumgartner. It happens. I'm wrong about stuff all the time. Individual scientists can be wrong. Science as a whole can be wrong. It's less likely, or it probably happens less often than an individual. But we're all human. We all have our own opinions of things. And the quotes that you have provided are opinions. They are not scientific. They are not science. They are not data as applied to empirical evidence, which is what science is. This notion that we are just making things up again is it's insulting, because there are honest, there are people of great intelligence that are that have devoted their lives to this, and to say that they are just simply pulling this out of their tuchus demeans that work, demeans the devotion that those folks have had with their science, and it's uncalled for. If you are going to attack the argument, if you are going to say that that Big Bang is not the correct cosmology, then you'd best back that up. Big Bang cosmology has its problems. There are questions that it cannot answer. There are things that we observe that at present the Big Bang model was not able to predict accurately, or actually make any real predictions at all. That may be overstating it, but just because a theory has problems doesn't mean that it needs to be thrown out a baby with bathwater. You need observations, more observations. You need continued study to test whether or not these things are falsified. Nothing so far has falsified the Big Bang theory. Nothing has falsified that dark energy doesn't exist. Yes, we can't explain dark energy very well, particularly at the fundamental physical level. But does that mean it does not exist? No, it doesn't. It could exist, or it could not exist. It could be a mathematical fudge factor, or it could be a gateway to an understanding of the universe unlike anything we have seen before. We don't know. And again, this work by and opinions by Witsit, by other truthers, or however you want to call it, they deal in absolutes, unless it can which is ironic as hell because no one on the Flat Earth movement or in the Flat Earth Society has an absolute description of the universe that even accounts for really anything. As I mentioned in the beginning of this, near the beginning of the stream, the Flat Earth community is not monolithic at all in any sense of the word. They have no concise description of anything that they all, or even have a consensus of, other than the Earth is not a globe. That's the only thing that if you were to ask a flat earther or true earther, the only thing they will all agree on, or even most of them will agree on, not all of them, is that the Earth is not a globe. Not that the Earth is flat. Some of them don't even go that far. Like Bev and his Bevites. No, the Earth is not flat because it has topography. Science skeptics and evangelical Christians deal in absolutes. Things must be absolutely right. If it's not absolutely right, not even that. If there are questions, if you can question something, then it's wrong. If you question Big Bang, if there are questions that Big Bang cannot answer, Big Bang doesn't exist. It's wrong. Yet there are many questions that Flat Earth cannot answer. And yet it's right? Oh no, we don't have a model. That fucking cop-out. Bible, if you question God, well, you can't question God. God is absolute. God is there. You cannot question. You cannot have doubts. So this idea of having doubts, this idea of not knowing everything, is anathema. No, it has to be. You have to have answers. You have to have answers to everything, or you're not right, or you can't make any kind of statements at all. How does one live in that universe? How does one live in a society, or how does one go through life needing absolute certainty in everything? They don't. They only seem to cherry pick what absolutes they need. When it comes to the universe, when it comes to the shape of the Earth and whatever, they need an absolute framework that is right 100% of the time. In other aspects of life, it doesn't seem to really bother them. Fuck. Only Sith deal. Only Sith deals in absolutes. That's an absolute fact. That's true. Scientists don't just make things up. We can take great care to construct tests that provide a definitive answer. I'm a little tired of making shit up. Yeah, I'm really like I said. All right. Well, thank you. I don't know. Let me see if I can find it. I don't know where that screen went to. Maybe it's over here. No. I am curious to know how many people are currently watching. And I don't think what is this? That one? Hey! 22 people! Holy crow! Holy! You guys have been with me for 4 hours? Wow. I'm actually kind of touched by that. Wow. All right. Anyway, I was expecting like 4 people. Anyway, that is amazing to me. Anyway, so yeah, I hope you all have enjoyed this. I have, even though I didn't really prepare for it very well. And I'm sure I have irritated some out there somewhere, and I will hear about it. But it is what it is. I don't think that I have said anything that I would retract. I don't think I've said anything that I've felt I've gone too far on. I have lost a little bit of my patience, which I'm not exactly happy with, but it is what it is. Anyway, I have been Professor Parks, PhD, and this has been a dive into relational mechanics. Those of you who came in late, the first hour or so, I looked at a book which Dr. Sun Genesis cites at the very beginning about relational mechanics, and I talk about the issues that I have with it, mainly the issues surrounding the fact that I don't understand how they can make the claim that all forces in the universe are zero, summed to zero, and that the orbits of the planets, and because of that, the orbits of the planets in the solar system are in fact significantly affected by the mass of the universe. So I went into that, and then I just went down the rabbit hole for hours into Sun Genesis, and I don't think I've even I haven't even touched the surface of it. So, Hugh Jarvis is starting his stream right now. So yes, everyone go over to Hugh Jarvis, support him and Mr. 42. As always, please like, share, and subscribe. Very much appreciate it. Thank you to my patrons, Judy Bassett and Nora DeCou. And if you'd like to support me financially in doing this and support the observatory, please consider becoming one of my patrons. And I think that is all, folks. So I'll see you next time. Peace out and clear skies.